Unul singur, da? Păi, practic, o să se ruleze.
Bună dimineața! Haideți să ne luăm locurile și să începem. Hello, good morning. Please take your places in order to start as fast as possible. We had some problems, some technical problems with the stream, but now they are solved and we can start. We have the stream on YouTube and Facebook.
Yeah.
I want to check, yes? I believe it is about.
Okay, good morning. Bună dimineața. For those who are not speaking Romanian, you can see how you can spell it. I will continue my speaking English because it's easier for everybody to understand. But we also have the translation system from English to Romanian and from Romanian to English. You can use the headphones if you want to understand better. This event is hosted by Asociația Interlan. Asociația Interlan, Interlan Association, is a not-for-profit organization of network operators in Romania, which is responsible for finding the sponsor, the right venue, and managing the necessary expenses for the event organization. And the program is selected by the program committee. The program committee is a group of Romanian volunteers that ensure that presentations are aligned with standards commonly followed at NOKS. Presentations will be held in both Romanian and English, as I said before, and you can use the headphones if you need. What we expect from you: to be open, considerate, and respectful, embrace diverse viewpoints and experiences, recognize the efforts of community members, show empathy, especially in disagreements, collaborate openly and work well with others, prioritize the community's interests and follow its processes, give and receive feedback positively, and use inclusive and welcoming language here at this event, of course. And some housekeeping. This event is being recorded. If you do not wish to appear in our published materials, photos or whatever, please inform the registration desk and we will proceed accordingly. Please set your phones now to silent mode if it's possible. Thank you. And if you would like to ask questions, please state your name and affiliation first. And of course, you can report anything, any issues to our staff, any concerns. Roxana, Andrea, and Angela. I don't know if Angela is there. And Andrea is there at the door. Okay, so let's go with a short history of Ronog. We started the first Ronog edition in 2014. We hosted the 25th URX Forum in Romania. URX is an organization of internet exchanges. And they proposed to organize the first NOG, so that's how Ronog was born in 2014. I will go faster between the slides. We had Ronog, the second edition next year, with almost the same numbers. In 2016, we started to organize it with RIPE training courses. And that edition, we combined it with the IRN meeting from ISOC. Of course, next year we had again the RIPE training days, and we also had the RIPE member lunch. 2018, again, the numbers were increasing. 2019, we had again the training days and big numbers. And then we had COVID for 2 years, and we postponed the event. And then in 2022, we came back, and we came back online, on site. Last year, we had also increasing number in attendees and speakers and topics. As I said before, the Ronog Program Committee is a group of Romanian volunteers. They are responsible for the content, and the content is provided independently. So it's not decided by the organizer. Today's agenda, we will have 4 sessions. That's the primary, the opening plenary, which will be chaired by Virgil Truică. Virgil is here, okay. And then after the coffee break, we will have the second plenary chaired by Tiberiu Gîndu. Is here, Tiberiu? Not, he will come. He will come. After the lunch break, we will have the third plenary chaired by Alexandru Rotaru. And he's there, okay. And after the closing plenary, chaired by my colleague Angela Stănescu, we will have a Kahoot quiz. So you have to watch the presentations if you want to know the answers at the Kahoot quiz at the end. And then we will wrap up, and we will go to the party at Naive. Naive will host the 19th anniversary of Interland. I think you all know the venue. It's in the city center, and you just have to flash your badge for entry, and the dress code is casual or whatever makes you want to dance. We have a lot of speakers today at Ronog, and a full day of presentations. At the end, I will like to tell you about the events that will happen in the next year. So we will have some major events in Romania, in Bucharest, wait, I'm one slide forward. Connected events today. Yesterday we had the Internet Measurement Day with together with RPCC and ICANN, and tomorrow and the day after tomorrow we'll have 2 training courses. Tomorrow we'll have the IPv6 training course and the RIPE database training course. There are a lot of resources on the net, on the web. You can check our official website, and also we are on the social platforms, and we have a YouTube channel. A big thank you to our sponsors, Digital Realty, IPXO, Internet Society Foundation, TP-Link, EXA, Telegroup, Salumanus, Smart Optics, NOKIA, Flex Optics, EncryptNet, NX Data, Noxion, IP Host Data Center, Flex Optics, again, Genie Networks, RIPE-NCC, Netera, RETN, Sphere, Echo, Infinity Telecom, Viva Telecom, and of course the hosts of this event, Interland Internet Exchange. And as I started to say before, we will have some connected events next year. The European peering, not connected, some major events next year, sorry. We will have the European Peering Forum in September in Bucharest, Romania. Many of you attended the past EPFs, and you know what it's all about. And Ronog will be right after the European Peering Forum in September, and 1 month later we will have the RIPE 91 meeting here in Bucharest, and the Interland Internet Exchange will be the host of this meeting, 10 years after the first RIPE meeting in Bucharest, which was in 2015. So that's been said, and because we are in a little bit of late, I will give the mic to Virgil, and you can...
Thank you, Eric. Good morning, everyone, and welcome. First of all, congratulations for being on time. I know many of you stayed up late last night. I know because I was there. We'll start. My name is Virgil Truică. I will be introducing the amazing speakers we have in the first plenary of today. And as Eric said, let's kick off. We first have Mikhail Puzanov from RPKI. A round of applause, please.
Good morning, everyone. So I'm Mikhail. I work for RIPE-NCC, and that's a slightly catchy title for the presentation about RPKI. I would assume everybody here knows what it is. If you, by some reason, don't, you should absolutely check it out. Yeah, so it's about some generic things happening in our RPKI field. It's also about the things that we in RIPE-NCC do about it, something that we have done and something that we're planning to do. And it's also dedicated to ISPA, partially as the sort of a next, as we expect to be a next big thing in this field. And quite likely you're going to hear about it a lot in the future. So this is a graph of what we call RPKI adoption. This is essentially a number of CA certificates that we have for different RIRs. And this is the last 4 years. And before that, the graphs were actually very low, so it wasn't very interesting to look at them. Here we see still a very steady growth. So at the moment, RIPE-NCC has slightly above 21,000 certificates. And the number is still growing, and it's growing for pretty much everybody, except for, in this case, LECNIC, but I believe it has to do with some local restructuring and stuff like that. So yeah, this whole thing is still on the rise. So and we expect it to be the case in the future as well. Similar thing comes to prefixes. So in this case, it's amount of let's say IPv4 addresses in the /24 units, let's say. And the same picture is here. We still see the very steady growth, especially as you can see for ARIN. They actually even have more prefixes now than covered by RPKI than RIPE-NCC has, which is an interesting thing. Sorry? Oh, okay. So it should be closer to the microphone, probably. Yeah, okay. So even more interesting situation with IPv6 in /48 units. So we have also quite, well, overall we have quite serious growth. And as you can see for ARIN, there was a huge jump in the beginning of the year that probably has to do with, I'm not sure exactly what. It probably has to do with Amazon deploying a bigger RPKI infrastructure there. But yeah, I may be wrong about it, but there was some event that could have caused such a spike in the amount of prefixes there. Okay, so this is about the sort of there was about the certificates and the coverage, but probably even more important part of RPKI is validation. Creating the raw objects for your resources is one thing, and validation is actually using these objects for protecting the networks. And this year, a couple of months ago, there was a pretty interesting milestone. Yeah, there's a link there to this Kentic website. Basically, according to the measurements, now more than 50% of IPv4 traffic is covered by the RAWs, and the same was for IPv6 probably last year, something like that. It happened even earlier. So now we can sort of officially say that more than half of all the traffic in the internet comes through RPKI protected, let's say, routes. And also the other measurement project called RoVista. It's quite interesting one. According to this project, about 90% of all networks are currently protected by RPKI, at least partially, and 22% at the moment of making this presentation are fully protected. Protected means that from this specific IS, you cannot reach a prefix that is made invalid by an RPKI RAW. So the RoVista established actually multiple points and made them intentionally invalid, made these routes intentionally invalid, and was measuring if these points are reachable from the IS that is being measured. And that's basically how it gives the scores to these IS numbers. And as you can see that about 20+% of them are not capable of reaching the invalids at all. And somehow about 90% of them are 90% of them are not able to reach some of these invalids. So that has quite a big impact already on the routing. So for the validation, there's multiple options for the software. They are all pretty solid by now. It's been multiple years of development and testing of all this software. So you can, again, use the link, look it up. So they're by now all pretty well tested, easy to install, and all that stuff. So in that sense, the adoption is, in that sense, the deployment is actually quite easy. Okay, so the RIPE-NCC part. So what do we do about it? So right now, as I said, we have more than 21,000 certificates. The potential for growth here is more than 40,000 because we have 20-something thousand members and about the same number of end users. These numbers look kind of similar to each other, but it's by accident. It's not really that related to each other. So we have about 46,000 of AS numbers protected by ROAS, essentially. And 276K of VRPs, the validated raw payloads, which basically means that about a fifth of the whole routing table is covered by ROAS from RIPE-NCC, or RIPE-NCC and other nested CA repositories. Okay, so what we have done or are doing at the moment. So the biggest thing that is we're busy with now is the new RPKI dashboard. It's a new UI, it's a slightly new backend. There's a lot of different workflows that are sort of improved or optimized or made it easier. And we did a lot of we did some focus groups, we did testing with the users. So by now it should be handier than the UI that we already have. We have some people who cannot use the existing UI because they have some enormous amount of prefixes and announcements that they need to cover. And this UI basically unusable. For these people, there's API existing, actually. They can script all this stuff, but some of them still want to use the UI by some reason with all this a huge amount of data. So anyway, that's also being taken care of. And again, there's lots of bug fixes. The plan is that in a couple of weeks, it should go live. That's a sort of tentative plan. It's not commitment here. But yeah, our intention is to present it before the RIPE meeting. The whole RPKI in RIPE-NCC is now ISAE 3000 Type 1 certified. That basically means all the processes are described. We have all the proofs for all the procedures happening internally, from signing to, I don't know, database backups, deployments, all that. So basically everything we do about it is now having all the documentation and all the things. And the other thing is the not that very noticeable, but we have our sync servers that are upgraded and actually have much increased capacity now. It's a different type of deployment. So now we can actually be sure that in case of our DP repository goes down, our sync will be able to hold the load. So what we're going to do is migrating the hardware security module for the trust anchor, since we are one of the 5 trust anchors that needs to be taken care of. It's a tedious process that's going on, so we'll get there. We're planning to do some improvements on the history of the rows in the UI so that people can actually see what happened, who did the change, why it happened probably, potentially have the functionality to roll back to a certain state, because we've seen multiple issues when people get lost in their own changes, and that would help a lot. There's quite some plan about ISPA support, Autonomous System Provider Authorization. So currently it works on test through the API in test, but we are going to go to production with it. And routers BGP certificate support and RPKI assigned checklists. There's some demand in the community for that. Okay, so the last piece of ISPA. So what is it essentially? It's yet another type of RPKI objects that describes hops in the AS path. So it encodes the provider-customer relationships. It is being signed by the holder of the ASN. It's supposed to be verified by RPKI validators. As usually, it's passed to the routers. And it's supposed to protect from the cases of IS path spoofing or similar. And for the situations where route origin validation may fail to protect, ISPA is supposed to actually protect against these cases. So currently, it's pretty close to become a bunch of IETF RFCs for the description of the object itself, the verification of it in the routers, and the RTR protocol. It's all technical details, but basically, there are a bunch of drafts that are all pretty close to become RFCs. So RIPE-NTC support in the test environment, so people can actually, you can play around with it if you feel like it. Validators already have some implementation for it, and at least most of them. And there are even a couple of routers implementations, so also for people who want to actually try these things. And yeah, that concludes the presentation. And if you have any questions, please go ahead.
Thank you, Mikhail. Are there any questions in the room? No? Well, you can catch up with Mikhail in the coffee break. So thank you again.
Thank you.
Next, we have Vlad Moise from TP-Link talking about solutions for networking and video surveillance. Vlad, you have the floor.
Salutare tuturor! Cum îi dăm mai departe? Nu nimic. E ok? E ok. Mersi mult. Salutare tuturor! Mulțumim pentru participare. Mi-am dat seama că prezentarea pe care am pregătit-o pentru astăzi e un pic cam lungă. O să încerc să trec așa repede prin ea, astfel încât să lăsăm un pic de timp la final și pentru câteva întrebări, dacă sunt, sper să fie. Haideți să-i dăm drumul. Cine suntem? Probabil mulți dintre dumneavoastră ați auzit deja de noi, știți cine este TP-Link, probabil aveți și acasă. Mulți dintre dumneavoastră știți probabil de soluțiile noastre de consumer, pentru că probabil ați interacționat cu ele. Astăzi o să vorbim în schimb despre soluțiile de business, suntem în alt cadru, să spunem. Cine este TP-Link? În mare, în câteva cuvinte, o companie de tehnologie înființată în 1996. Scuze. Prezent în 42 de țări prin subsidiare și cu prezență în 170 de țări în total. Avem 2 sedii, unul în Irvine, California, altul în Singapore, 4 centre de cercetare și dezvoltare, unul în Statele Unite, restul în China. Avem 3 centre de manufactură, China, Vietnam și mai nou din 2024 în Brazilia, unde am început producția de Wi-Fi 7. De 13 ani suntem numărul 1 în privința echipamentelor Wi-Fi vândute și aici includem atât partea de consumer cât și partea de B2B. De 6 ani consecutiv recunoscuți în Gartner Magic Quadrant pentru soluțiile de rețelistică business, wired și wireless. Aici sunt prezente câteva dintre subbrandurile noastre, probabil unele dintre ele le știți deja, cel puțin cele din gama consumer, cu toții probabil le-ați văzut sau poate le și aveți. Dar mai sunt aici 3 branduri pe care probabil unii dintre noastre nu le știți. Unul dintre ele este Aginet, este soluția noastră dedicată service providerilor. Un alt subbrand este Omada, este soluția noastră de rețelistică profesională și Vigi este soluția noastră de supraveghere video profesională. Atât Omada cât și Vigi sunt prezente la standul nostru, deci oricând după prezentări sau în pauze putem discuta acolo, putem detalia și le putem arăta pentru că sunt funcționale. Cei dintre noastre care ați fost anul trecut la Ronog, vă spuneam atunci că suntem primul vendor care a lansat Wi-Fi 7 atât pentru zona de consumer cât și pentru zona de B2B. Anul acesta, după cum știți, Ancom în martie a deschis oficial vânzările pentru Wi-Fi 7, adică a reglementat spectrul. Motiv pentru care am început deja vânzările de Wi-Fi 7 atât pentru zona de consumer cât și pentru gama de B2B. Aici sunt echipamentele din toate gamele noastre pentru partea de Wi-Fi 7. Mai departe, legat de partea de business, vă ziceam că Omada este soluția noastră de rețelistică profesională. Anul acesta am lansat și Omada Pro. Omada Pro, dacă Omada, cei dintre noastre care știți despre Omada, ați văzut că este disponibilă cam în toate canalele noastre de vânzare, adică aici includem și partea de online, astfel încât în momentul în care lucrați pe un proiect, există posibilitatea să mai fie și alți integratori care ofertează pentru acel proiect. Gama Omada Pro este destinată proiectelor, nu va exista în zona de online, se accesează doar prin înregistrarea de proiect, cu discounturi în funcție de dimensiunea proiectului, bineînțeles cu discounturi undeva de până la 80%. Undeva spre finalul acestui an vom lansa și o platformă care unește cele două soluții, adică atât partea de rețelistică, cât și partea de Vigi, partea de supraveghere video. Platforma se va numi Omada Central. Ea există deja, lucrăm pe ea, o testăm, dar nu este încă disponibilă publicului larg. Undeva spre finalul anului, nu știu, noiembrie-decembrie ar trebui să fie lansată. Oricum o să facem un anunț public când va fi disponibil. Ce este Omada? Unii dintre noastre probabil deja ați interacționat, alții nu. Spre deosebire de o soluție clasică de rețelistică, unde avem router, switch-uri, access point-uri, în Omada mai avem un element în plus, partea de controller. Ce face controllerul? Ne ajută să administrăm în mod centralizat toată rețeaua. El practic este ca un, să zicem, capitan al unei echipe. Spune fiecărui echipament ce are de făcut în echipă. El administrează partea de Wi-Fi, să zicem, adică distribuie în mod centralizat toate setările pentru partea de access point-uri. Să zicem că avem o rețea cu 100 de access point-uri, 20 de switch-uri, un router. În mod tradițional ar trebui să intrăm pe fiecare echipament, să-l configurăm, ceea ce ne-ar lua o zi, 2 zile, habar n-am, depinde cât de rapid suntem. În Omada, practic, setările de bază pentru a pune o rețea în picioare ar dura undeva la 10 minute, probabil. Toate setările de routing sunt trimise din controller, toate setările de switching, indiferent câte switch-uri sunt, la fel sunt transmise în mod centralizat. La fel și partea de Wi-Fi, SSID, parolă, ele sunt transmise concomitent către toate access point-urile. Ce cuprinde partea de OMADA? Când vorbim de controlere, sunt 3 categorii de controlere. Controlere hardware cu capabilități diferite, până la 100, 500, 1000 de access point-uri care pot fi adoptate. Există un controller software care este gratuit, poate gestiona până la 10.000 de access point-uri și un controller cloud nelimitat. Nu există o limită de echipamente. Câteva beneficii, să zicem, sau de ce ați alege OMADA versus alte soluții din piață. Pentru că mai există soluții în piață cu o modalitate asemănătoare de implementare. Păi, în primul rând, există disponibilitate, există depozit local, depozitul din România deservește întreaga regiune, deci nu e o problemă de stocuri, garanție by default 5 ani, organizăm traininguri de certificare, aici local în limba română, cu noi, aducem echipamente, putem să facem hands-on experience, există partea de suport tehnic dedicat, atât colegii de la pre-sales cât și after-sales, astfel că nu e nevoie să intrați pe forumuri sau diferite metode prin care să solicitați suport, scris mail unui chinez și așa mai departe. Din punct de vedere al proiectelor, păi deja OMADA este din 2018, astfel că am reușit să penetrăm cam toate verticalele posibile. Aici, local, în România, de la proiecte micuțe din zona de Horeca, de exemplu, la spitale mari de stat, spitale private, aeroporturi. Am făcut câteva evenimente cu câțiva parteneri de-ai noștri, evenimente destul de mari, unde am avut peste 200 de access point-uri. Putem detalia după, nu avem încă ok-ul să le prezentăm așa public. O să avem niște studii de caz și acolo să detaliem. Bun. Mai departe, pentru a susține infrastructura pentru Wi-Fi 7. Știți că sunt vitezele acelea foarte mari. Și pe partea de cablu trebuie să avem la fel echipamente foarte performante să susțină Wi-Fi 7. Astfel că avem rutere switch-uri cu 10 gigabit pentru a susține acele viteze mari. Încerc să mă grăbesc un pic. La partea de access point-uri, după cum ziceam, Wi-Fi 7, Wi-Fi 6, porturi de 10 gigabit, porturi de 2,5 gigabit. La fel la partea de switch-uri, switch-uri cu management, switch-uri fără management, 2,5, 10 gigabit, cu PoE, fără PoE, o gamă foarte extinsă. La fel partea de switch-uri fără management. Câteva noutăți, și aici o să trecem destul de repede prin ele. Foarte important, am lansat OMADA Cloud Controller gratuit. Există într-adevăr niște opțiuni care lipsesc versus cloudul plătit, dar puteți administra nelimitat echipamente OMADA fără să aveți un controller hardware, fără să plătiți licențe. O rețea de bază e absolut suficient, OMADA Essential. Mai nou, anul trecut m-ați întrebat dacă partea de GPON este administrată în OMADA. La momentul respectiv nu, dar pentru că au fost suficient de multe solicitări din piață, acum inclusiv partea de OLT-uri, mai nou am lansat chiar acum recent, în septembrie am adus în țară access point-urile Wi-Fi 6, GPON, deci sunt deja disponibile, putem să facem infrastructura complet pe fibră. Aici sunt câteva detalii despre access point-urile GPON. Partea de rutere s-a îmbogățit destul de tare, de la echipamente care pot susține infrastructuri relativ micuțe până la soluții enterprise. De exemplu, acesta este un router 10 gigabit, până la 11 provider se pot conecta în el, adică are până la 11 vanuri. Un alt router interesant, care nu mă gândeam că o să-l avem, este un router care are și partea de access point pe el, un Wi-Fi 6. Un model asemănător care are și redundanță pe 4G, adică are un modem 4G incorporat. Acesta îl avem chiar la standul nostru, îl putem arăta. Un alt router interesant este un 3 în 1, care are și partea de controller și partea de switch PoE, astfel încât într-un proiect bicuț, o școală, un birou, e nevoie de un singur echipament și restul access point-uri conectate direct în el. Switch-urile Layer 2, Layer 3, switch-uri, să zicem, la nivel industrial, cu redundanță pe partea de alimentare, de răcire, se face hot swap. Mai nou urmează să lansăm switch-urile industriale, ceea ce lipsea din portofoliul nostru. Un switch nou foarte interesant pentru outdoor, cu alimentare prin PoE, în general pentru zona de supraveghere video. Câteva cuvinte despre soluția noastră de supraveghere video pe care la fel o avem aici disponibilă. E deja o soluție matură, chiar dacă noi abia recent, de anul acesta, am început să o promovăm mai intens în România. E un environment complet, adică și partea de software și partea de hardware. Camerele, o gamă destul de completă, de la 2 mega la 8 megapixel în toate format factorurile. La partea de NVR-uri, la fel, de la 4 la 128 de porturi. Sunt și cu PoE cele de 4-8 porturi. Soluție de panouri solare, sunt niște kituri. Putem să facem o soluție de supraveghere video total independentă. Avem camere cu 4G și kiturile acestea de panouri solare. Sunt deja disponibile, sunt în România. Cum vă ziceam, partea de software, există tot felul de tool-uri de configurare. Omada Central, despre care vă povesteam că va fi disponibilă undeva spre finalul anului și va integra atât partea de supraveghere video cât și partea de rețelistică. Și câteva cuvinte în încheiere despre noi. De ce vă invităm să luați legătura cu noi? De ce vă invităm să lucrăm împreună? În primul rând, pentru zona de proiecte B2B, avem prezență locală. Vă putem ajuta cu înregistrarea unui proiect, putem să vă ajutăm cu suport în identificarea unei soluții corespunzătoare. Există suport din punct de vedere pre-sales, la fel pentru identificarea soluției, pentru a dimensiona corect o soluție. Partea de training-uri, de certificare, despre care vă povesteam mai devreme. Stocuri, permanent. Și suntem foarte prietenoși, o să vedeți când ne vizitați la standul nostru. Cam atât din partea mea. Dacă mai avem timp pentru întrebări, eu sunt deschis.
Thank you, Vlad. Yes, we do have time for questions. I personally use 2 devices TP-Link at home, and probably all my friends do. So if you have any questions for Vlad? No question now? Okay, well, you can meet him and his team outside.
Vă așteptăm la standul nostru. Vă mulțumesc mult.
Okay, our next speaker is Goran Doreski from Digital Realty. Goran, you have the floor.
Hello everyone, it's great to be here with you. I'm Goran Doreski, I'm Managing Director of Zagreb office of Digital Realty. One part of our presence here is, our presence in the region is also Romania. So my colleague Dorian here, he is responsible for this market and few other markets. Being a local guy, also he knows quite a lot about the market. I will now say a few words about us, about how our work exists in the context of the communication of the global data center business, and actually how does that influence whatever you do. We're a global organization present in more than 300 data centers in the world. In that way, we are the biggest global organization of carrier independent data centers. The good point here at this slide is that in the case that you have a need anywhere on the map, you don't need to go to any of these cities. You just speak to Dorian, and Dorian would be able to arrange anything for you, whatever your need is and wherever it is. We don't want to speak too much about the carrier neutrality. It proved to be globally the most beneficial approach to the data center business from the perspective of current needs, price, but especially from the perspective of the growth of the business in the future. The greatest flexibility comes in the carrier independent data centers, and this is also obvious from the perspective of the hyperscale customers, which also always choose the carrier independent organizations. The main topic of today's speech here is about the Mediterranean strategy and what is going to happen in the Mediterranean, how it's going to influence our region. So in the context of Mediterranean, the way that we have seen it up to now is that Marseille was the main digital hub of the Mediterranean, and most of the communication coming to Europe, to the flap markets from Asia was coming through Mediterranean and then to Marseille. What we see and what we also try to enhance in the future years is transforming in the way that not only Marseille would be an important digital hub, but that Mediterranean as whole would become a digital hub. And there are reasons for that, and this is already ongoing development. So looking at the number of POPs in the region of the Mediterranean, which is represented with the size of this circle, you can see that it's quite densely populated area with the network connectivity. The ones which are a little bit more in blue, it's not very visible, but you can see where digital Realty is present at the moment. So why is it important, and why now? What we see now is that the capacity which is currently being installed in the Mediterranean fiber is now growing in the way that in a few years from now the capacity will grow tenfold compared to what we have right now. And this is creating the big opportunity for everyone because this capacity needs to be served around Europe. Position of the Mediterranean is such that is very close latency-wise to a big portion of the global population and a big portion of the global economy. So this is the reason, and also Africa is emerging market. And we are present in 4 markets now in Africa as well, is close. So kind of this is going to be and is becoming increasingly the connection point. If you look at how do we as a digital realty address this topic, the places which are marked in blue, so meaning Madrid, Marseille, Zagreb and Athens are the places where we already have active data centers and from which we serve communication partners already quite densely. And the places which are in black, this is Barcelona, Rome, Crete, and Tel Aviv, are the places where we are developing our data centers additionally. So, and then in this table you can see the latencies towards the flap markets from the Mediterranean data centers, and you will see that these are very small latencies, very low latencies, which actually enable us to approach the flap markets in a very convenient way. Seeing this picture, it's also easy to understand that we are now dedicated to the Mediterranean. This in the picture that you can see is that the active existing fiber, which is currently working in the Mediterranean, is in the blue, and in purple you can see the planned ones. So development is quite high, and we expect in the next few years also Crete to become increasingly important location where many of these fibers will intersect. Our development is not on the south node from Africa, but there are some partners that will also develop the communications from the south. As I mentioned before, in this region, we cover the whole region from Zagreb. There is Athens on the south that is turned a little bit more to the Mediterranean area itself, and this region is being covered mostly from Zagreb. So why Zagreb? Zagreb is a place where we already have more than 50 telecoms interconnecting. There are low latencies from Zagreb to anywhere in the region, or from Athens if you're closer to Athens. And very importantly, Zagreb is at the moment at the direct and very short fiber path from the Mediterranean to the Western European hubs, which are currently bearing most of the traffic. So the shortest connection way would be through Zagreb. What is our plan for Zagreb? We are currently preparing the build of 10 megawatt facility, 6.5 megawatt of IT power in Zagreb, and the total campus area that is where we are building this also is included the plans for Zagreb 3 as well, which is together with Zagreb 2 going to provide 30 megawatts of IT power. This is so the first plan. So Zagreb 2 is planned by the middle of 2026, and the rest is planned by the end of the decade. We believe that such approach will also help the region to bring some of the hyperscale provider closer from the Western Europe to this region, but at the same time to bring that to bring the rest of us closer to them as well by utilizing the capacities in Zagreb. Okay, and this would be all from me right now. If you, I don't know whether you have some questions regarding my presentation. Yes, please.
Thank you, Goran. We have a question here.
Do you have plans for Balkan areas and especially Romania, a country around?
This is the most expected question. I thought that somebody will ask that. So we do not see any immediate plan to go into Romania right now, but we also do not stop looking at the market. So if when we are entering certain markets, there is a number of parameters that we check, and if we will be able to match all the parameters which are required for us to get into the market, there is no reason not to enter directly. In the meanwhile, we are covering the region from Zagreb and Athens, and speaking to Dorian, who is working here in Romania, we are quite successful in providing our services either from Zagreb or from any other data centers around the world to the local. But I can see that Romania is a big and significant market, and it has a need. Just all of the puzzle didn't fit yet.
Any other question? Thank you, Goran.
Okay, then I would give a chance to my friend Mohamed to give a little bit more about ServiceFabric, and this is the way how we patch together our data centers in the communication way. Thank you.
Thank you for your help.
Hello, happy to be here. So my name is Mohamed Sahnine. I'm Global Solution Architect for Digital Realty. I'm based in Paris. And today I will present you our ServiceFabric platforms. So it's an SDN platform that helps customers to perform their orchestration on hybrid IT. So if you are familiar with Megaport, Equinix Fabric, and all these kind of services, it is really similar, but there is some key difference that I will explain today. Before going in detail on this platform, I would like just to to explain our strategy and what we believe in digital reality. So we really believe that the data gravity is important. So we develop a formula and we develop an index that help customers to know where exactly they have to deploy. For instance, I'm a finance company. I want to be deployed in some location. So we have 300 data centers in the world. So I will help this company to select the right location and to connect their location with our data center. So in our vision, we think that we should do something open. So we are working with partners like network providers, AX providers. So we are not bringing our own champagne every day. So we are building our platform based on your services, on partner services, network services, and we put that in our platform. We automatize this infrastructure with our APIs, and we deliver the services to the customer. So I will explain a little bit on our vision on hybrid IT. So it is not something new. So hybrid IT is something that CTO are considering since a while. So we can see from the market that many customers move to the cloud. That's a fact. But there is also many customers, they want to stay in the data centers. They want to exit from their existing data center because it's very old, not sustainable, very costly to operate. And they are using our data centers, which is modern, very well connected, carrier neutral, and to deploy their infrastructure. But they want to consume the cloud. And they want also to consider different locations, not, for instance, I want to deploy in Athens or in Zagreb, but maybe I want to create a disaster recovery site in Paris, and I want to interconnect both sites. So this is possible with our platform, and I will show you how. So ServiceFabric, the vision is that it is an open platform. We develop a bunch of APIs, so full on-demand APIs, and we are working with partners. So we have our own network connecting 150 data centers in the world, but we also define some NNIs with partners like Megaport, like Console Connect, and many telcos, AX providers, and the customer with just a portal or just clicking and selecting the location, deploying the port and creating virtual connection to consume the services. That's very simple. And we are using, of course, we are removing the complexity. We can also deliver APIs to developers if you want to integrate our platform to your services. So if you have any platform that you want to deliver to end customer, you can use our platforms and you will resell it. So in terms of design of building blocks, it's very simple. So basically, you have a customer who wants to connect to the cloud. He will have access to a portal. He will spin up a port. It's 1 gig, 10 gig, 100 gigs ports. And then from that, attached to his colo, he will create virtual connection to multi-cloud. Okay, you want to consume Azure, AWS, and then he has a second, for instance, he is based in Paris, and he has a secondary site in London. Then he can create a connection to London, to his colo in London with digital reality. But the power of the platform is that we are not locked to our ecosystem. Supposing this customer is also using a colocation to Equinix, for instance, in Dallas, then it's possible to connect the infrastructure in a minute. It just takes minutes and it's very fast. The other point I want to insist is the ecosystem. So if you have a provider of bare metal services, AX services, storage services, we can include you in our platform and present your capabilities to all our customers all over the world. So that's, if you have APIs, mature on-demand APIs, we can integrate your APIs and resell your services as well. This is unique in the market. Regarding network as a service product, we also deliver virtual router. So the new trend in the market today is to have multi-cloud. So customers, sometimes they don't need to have physical box in the data centers. They want to virtualize it. So they will deploy a multi-cloud virtual routers, connect to Azure, Google, etc., and run their workload like this. The service is full pay as you go. There is no setup cost, no engagement at all. So a customer who wants to deploy our services for a lift and shift project, he can do that, deploying the services, and when it's done, then it's done. He can remove it. This is the footprint. So today we are present in 150 data centers in the world. We are covering LATAM as well. Africa will come next year. We are connected, we have NNIs with 375 third-party data centers, and we can propose 250 on-ramp access. So we are the first row on on-ramp access with cloud in the market. So if you have any questions, so I will present the platform in our booth, and I can perform you a demo. So feel free to reach me. Thank you.
Thank you, Mohamed. Okay, we have one question. State your name and...
My name is Oleg. Mohamed, can you share more about the interconnection between data centers? This is a kind of private links, dedicated lines, or some multiple providers. What to use for this?
So thanks. So that's a good question. So we are using, we are selecting a bunch of network providers. So the major ones. So and we select them based on the latency and the performance. So we interconnect our data centers like this. But the idea, our objective is to automatize more providers and give the possibility to end customer to select. So for instance, I have a connection between Paris and Frankfurt. One would give me a latency up to maybe 7 milliseconds, another one to 10 milliseconds, and the price could be different. Then I will select the lowest latency if I need it, and if I'm driving the cost, I will select the other one. That's ultimately the vision we have to propose a fabric-to-fabric solution to our customer.
And we have another one.
Hi, Ben for BGP Tools. Did you say, sorry if I missed you saying this, you said it is no cost to start on this platform. How do you deal with things like the cross-connect fees? Is it paid by digital realty, or is it?
So cross-connect is included in the price of the ports, okay? But you have no setup cost. So meaning that if you want to be connected in one data center in London, for instance, you have a colo, so you need to have a colo. Okay, that's the only one. A patch panel, we deliver the port. 1 gig port is €150, and the cross connection is included. And just 1 month's engagement.
Any other questions? Oh. We have one from Dorian.
Just I want to tell you that there are several use cases that could be done with ServiceFabric. So it's important to understand that Romania could be part of ServiceFabric via different partners that we have locally in the market. Also any Balkan market that it's already enabled. So Sofia, it's already, we have a data center that is onboarded via Megaport in our platform. So in case that you want to understand more and how this platform is really working, so Mohamed will be all the day here and could give you some much more insights than a general presentation. Yeah. So thank you so much, Mohamed.
Thank you. Okay, next we have Lucian Popa from NOKIA. We'll be talking about selecting the right network processor and software for your network.
Bună ziua! Numele meu este Lucian Popa. Sunt inginer IP în cadrul companiei NOKIA România de 17 ani și am pregătit pentru astăzi câteva detalii, câteva aspecte despre tehnologiile procesoarelor și software-urile utilizate în echipamentele de telecomunicații. La finalul prezentării avem inclusiv un scurt demo de 3 minute care să explice o anumită tehnologie de protecție pentru atacurile de tip Distributed Denial of Service. Astăzi vom putea acoperi doar anumite aspecte în ceea ce privește tehnologiile din domeniul IP, data center și puțin partea de security și vă stăm la dispoziție și cu celelalte soluții sau tehnologii care pot fi de interes pentru dumneavoastră. Componentele de bază în ceea ce privește echipamentele IP sunt procesoarele de network procesorul și sistemele de operare. Pot fi 3 categorii de procesoare. Unele sunt dezvoltate de către producători, customizate și mai avansate. Există care se numesc Custom Developed Silicon. Există echipamente care utilizează procesoare de la diferiți producători de componente, cum ar fi Broadcom. Și ce este important este ca software-ul care este utilizat de aceste echipamente să fie un software de calitate. Deasupra echipamentelor se află partea de management, partea de automatizare, partea de controller, care necesită o discuție mai avansată și mai mult timp. Vom menționa doar câteva aspecte în legătură cu o soluție de protecție de tip Next Generation, de generație nouă DDoS Protection. În ceea ce privește procesoarele, în principal se pot împărți în 2 categorii. Procesoare care sunt fully buffered și partially buffered, în funcție de dimensiunea memoriei disponibile la nivelul procesorului. Dacă procesorul este fully buffered, echipamentul este capabil să proceseze throughput 100%, indiferent de numărul de flow-uri care se instanțiază pe acel network procesor. Există procesoare partially buffered, care în momentul în care se instanțiază un număr de flow-uri sau se activează servicii de tip, funcționalități de tip URPF, performanța acelor procesoare se degradează cu 50%, poate chiar mai mult. În cazul în care există un procesor fully buffered, performanța este stabilă și este multidimensională și deterministică. De asemenea, se poate observa o caracteristică importantă a procesoarelor este câte filtre suportă. Sunt procesoare care suportă mii de filtre, sunt procesoare care suportă zeci de mii de filtre, sunt procesoare care suportă sute de mii de filtre. Ce se poate observa este că unele din procesoare, în momentul în care se instanțiază un număr de filtre, performanța rămâne constantă și există altele la care performanța se degradează odată cu instanțierea acelor filtre. Este decizia fiecăruia să aleagă, în funcție de locul în care se poziționează echipamentul, ce tip de network procesor are nevoie. Bineînțeles că este bine să existe diversitate și opțiuni. În ceea ce privește procesoarele disponibile în piață, ele sunt în general, oferă capacitate, viteză și fiind mai simple, cu mai puține funcționalități, au un consum redus. Există și oferă interfețe în general între 1 și 400 de giga. Dar există niște procesoare mai capabile, care sunt în aceeași anvelopă de consum, sunt capabile să ofere și flexibilitate, sunt fully buffer și sunt complet programabile. De ce este important să fie 100% programabile? Este pentru că echipamentul se instalează astăzi, dar în timp apar noi procesoare, noi protocoale. Acele protocoale vor fi suportate de acele procesoare care sunt 100% programabile și nu vor fi nu se va putea implementa în cazul procesoarelor care sunt parțial programabile și atunci va fi nevoie să se înlocuiască acel echipament. Și, de asemenea, există procesoare care suportă encripție în hardware. Dacă encripția se face în hardware, este mult mai performant și cu un consum redus de energie. Alternativa este să existe niște chipuri dedicate pentru encripție în acele echipamente, care în momentul în care se activează funcția de encripție, consumul crește și performanța se degradează. Există procesoare, să le numim Network Processor Premium, cele din dreapta, care suportă inclusiv interfețe de 800 de giga single lambda și vor suporta și interfețe mai mari în momentul în care se vor standardiza, care sunt complet programabile fully buffered. Există procesoare care sunt optimizate pentru zona de agregare și care moștenesc caracteristicile procesoarelor premium și există procesoare mai simple, cele care provin de la diferiți furnizori, cum ar fi Broadcom. De asemenea, în piață există furnizori care oferă procesoare parțial programabile și care sunt poziționate și în zona de core, unde, cum am văzut, oferă doar viteză, dar nu oferă și celelalte funcționalități. Vom vedea de ce este important, pentru că la un moment dat investiția în echipamente se face pe un număr de ani, 3, 5, 10 ani de zile și este important ca echipamentele să aibă un total cost of ownership cât mai mic. În ceea ce privește arhitectura de data center, majoritatea vendorilor oferă soluții bazate pe chipseturi Broadcom. Diferența și arhitectura este de tip Layer 3. Inițial existau arhitecturi de tip Layer 2 care au evoluat către Layer 3 Fabric cu IPVPN și cu VXLAN. Aceste arhitecturi au la bază un underlay și un overlay Fabric. Tipurile de procesoare, familiile de procesoare de la Broadcom sunt Trident pentru leaf switches, Tomahawk sau Jericho pentru echipamentele de tip Spine, unde iar Tomahawk au buffere mai mici, Jericho au buffere mai mari și în funcție de aplicațiile respective se alege unul din cele două. Jericho se poate utiliza și pentru data center edge și în zona de out-of-band management se pot utiliza Broadcom sau Marvell, cum vom vedea. În partea de jos, arhitectura este de tip CLOS și în partea de jos se pot vedea evoluția tipurilor de generații. Inițial, data center Fabric erau proprietar și erau închis. Și de fiecare dată, dacă se făcea o modificare la nivel de kernel, de protocoale, necesita ca să aștepți vendorul să facă acea modificare. Între timp au evoluat către Linux și aici iară este foarte important să observăm diferențele, ce tip de distribuție de Linux utilizează fiecare vendor și cât de customizabilă, cât de deschisă este arhitectura respectivă și cât de scalabilă. Este importantă, de exemplu, să fie complet, să suporte mai multe distribuții de Linux și să fie capabile să fie complet programabile. Se numesc, să zicem, cele de generația a treia. Pe acest slide nu am prezentat soluțiile pentru inteligența artificială, care sunt bazate pe protocolul ROCE V2, adică RDMA over Converge Ethernet versiunea 2, care este o alternativă la Infinity Band, care este o soluție proprietară. Tipurile de procesoare care se regăsesc în Fabric, din câte vedeți, Marvell, de exemplu, este utilizat în partea de management switches și celelalte switch-uri. Este important peste acesta să existe sistemul de operare care să fie unmodified Linux și să permită patch-urile de securitate fără a fi nevoie să contactezi vendor, să fie complet decuplat și acel Linux, spre exemplu, sunt vendori care utilizează o distribuție similară cu CentOS-ul, dar CentOS-ul, din câte știți, a tranziționat de la un Linux stabil către o zonă mai de testare și există alții care utilizează Debian, din câte știți, e o distribuție care se utilizează inclusiv de către stația spațială. Și deasupra este nevoie pentru data center-uri foarte mari, cu sute de mii de servere, de o soluție de automatizare și de digital twin. În partea de calitate a softului, care sunt caracteristicile unui software de calitate, este cât de stabil este softul, cât de mult poate să funcționeze fără să creeze probleme în rețea, câte bug-uri are, dacă se pierd pachete sau nu se pierd pachete cu acel software, cât de mentenabil este, cât de testat este și partea de securitate de asemenea este foarte importantă, deoarece pot apărea vulnerabilități dacă nu există un control și o înclinare foarte importantă în a asigura un software sigur. Cum se poate asigura un software de calitate? Este în a aloca nu numai dezvoltatori, care poate să creeze foarte rapid anumite funcționalități, ci trebuie și testat. Iar optimul este să ai un număr de testori egal cu numărul de programatori. Dacă vendorul nu face testele respective, atunci se ajunge ca testarea să o facă clientul în rețea. Acesta este motivul pentru care la anumiți furnizori veți vedea anumite bug-uri în momentul în care testați și mai puține în cazul altor soluții. Este foarte important, sunt anumiți vendori care înainte de a lansa softul ca fiind general available, fac 350.000 de teste, echivalentul a 3 ani de testare, înainte de a lansa fiecare versiune de soft, astfel încât să se asigure că există calitate. La fiecare release de software sunt peste 400 de noi funcționalități care se introduc și trebuie să te asiguri că softul este de calitate. Iar calitatea se măsoară în timp. Dacă clientul este mulțumit, în timp de 10, 15, 20 de ani, atunci se observă acea calitate și stabilitatea inclusiv de la prima utilizare. În ceea ce privește securitatea, ea se poate măsura și prin numărul de vulnerabilități care apar pentru un anumit sistem de operare. Se poate observa că anumite sisteme de operare au un număr mic de vulnerabilități, pentru că se face o testare, există un proces de control al calității acelui software, astfel încât clientul să se focalizeze pe oferirea de servicii și nu de a face upgrade-uri doar de a rezolva anumite breșe de securitate. Un aspect în ceea ce privește partea de control procesor, modulul de control procesor are mai multe CPU cores. Este foarte important ca și software să suporte distribuția acelor task-uri peste acele CPU cores și necesită o atenție în partea de dezvoltare software. Se numește Symmetrical Multiprocessing. Se poate observa în partea de jos cum o soluție de Virtual Route Reflector distribuie task-urile egal pe 10 coruri. Aceasta ajută în scalabilitatea control plane-ului și în partea de convergență. Zonele de dezvoltare software sunt în zona de securitate, sunt în zona de Next Generation Services, EVPN, partea de segment routing, SRv6 și programabilitate, Model Driven, OpenConfig, NetConfiang și telemetrie. În ceea ce privește EVPN, este o soluție care ajută la reducerea complexității, astfel încât serviciile care se ofereau utilizând mai multe protocoale pot fi implementate cu ajutorul soluției de EVPN, unde ai un singur data plane și un singur control plane, mult mai eficient și îți va permite să oferi și servicii noi. De asemenea, este de menționat că nu toți furnizorii suportă toate aceste servicii de EVPN pe toate tipurile de procesoare. Deci la alegerea procesorului este important. În partea de segment routing, care de asemenea ajută să, în loc să ai LDP și RSVPT, poți să ai doar segment routing pentru IPv4, IPv6 și sunt mai mulți furnizori care oferă o astfel de soluție și sunt clienți care își doresc la un moment dat să treacă doar într-o rețea, să folosească doar un protocol de ServiceX, dar necesită o rețea complet IPv6. De menționat este că nu toate procesoarele sunt complet programabile și nu toate suportă ServiceX. Câteva inovații din ceea ce privește este important procesor, cum se poate vedea acel network procesor, dar este și important răcirea pentru a putea oferi o interfață de 800 de giga. Iar o inovație este să distribui componente pe ambele părți ale cartelei, astfel încât răcirea să se facă mult mai bine, dimensiunea radiatorului să fie la fel de mare și, practic, modulul optic să nu încălzească pe celălalt modul. Și mai există o inovație în ceea ce privește partea de airflow, inspirată din industria aeronautică, un mesh care permite aerului să treacă mult mai eficient, scăzând practic și consumul, și este un fel de Faraday cage, pentru că la un moment dat circuitele interioare funcționează, electrice din echipament funcționează la 112 GHz și există niște interferențe electromagnetice care trebuie protejate. În partea de DDoS, inițial au existat atacuri de tip spoofed attack, care te poți proteja prin anumite filtre sau o soluție clasică de DDoS mitigation. Din 2020 au apărut atacurile de tip botnet attack, în care practic toate device-urile conectate la internet pot fi folosite pentru atacurile de tip DDoS. Numărul de dispozitive este foarte mare, de ordinul miliardelor, și practic este din ce în ce mai greu pentru o soluție tradițională să facă față unor astfel de atacuri. Iar din 2024 s-a observat o creștere a atacului utilizând inteligența artificială, care sunt mult mai sofisticate, sunt multivendor și practic încearcă să simuleze un utilizator obișnuit. Pentru a face față astfel de atacuri există o soluție prin două nivele. Un nivel care poate să te protejeze în zona de edge, dacă, cum am văzut mai devreme, procesorul suportă instanțierea acelor filtre și performanța acelui echipament nu se degradează, iar pentru restul ai un scrubbing center. De asemenea, există clienți care, de exemplu, se bazeau pe soluția de scrubbing center foarte mult și atunci, odată cu creșterea traficului, traficul anual într-o rețea crește cam cu aproximativ 30% de la an la an, atunci tu, practic, partea de scrubbing center, de DDoS mitigation system, trebuie să o scalezi. Practic, trebuie să o crești cu 30% în fiecare an. Și nu este scalabil, consumă și energie și, practic, nu este eficient. Cel mai eficient este să faci mitigation la edge și doar pentru restul să protejezi cu un sistem avansat. Această protecție se poate realiza cu o anumită soluție în mai puțin de 30 de secunde. Detecție și mitigare. Deci imaginați-vă că aveți un atac în timpul nopții și practic soluția aceasta este un closed loop și te protejează. Diferența este că soluția existentă de DDoS are un trafic variabil, durează câteva minute și threshold-urile, acei parametri trebuie configurați manual și au un cost destul de mare. Alternativa este să se utilizeze o soluție de generație mai nouă în care protecția se face la nivel de sub 30 de secunde și este automată, line rate chirurgical la nivelul procesorului. Dacă rețelele sunt în prezent, există entități care colectează informațiile dumneavoastră sau informațiile guvernamentale, cele care din industria de apărare și diferite companii, astfel încât în momentul în care quantum computer vor fi suficient de avansați, vor putea să decripteze acele informații. Vă puteți proteja rețelele folosind quantum safe networks. Aceste rețele se securizează la nivel layer 1 de VDM și la nivel layer 2, layer 2,5, layer 3 IP, quantum safe encryption și quantum safe distribution keys. Este foarte important și distribuția cheilor să se facă într-un mod eficient și quantum safe. NISEC-ul este această soluție care îți permite la nivel de CPU. MACSEC-ul are un dezavantaj că este doar punct la punct. Partea de IPsec este foarte CPU-intensiv și este doar la nivel de IP. Dacă vrei să încriptezi traficul la nivel general și la nivel de MPLS, soluția este NISEC, care folosește protocoale de tipul MACSEC, complet compatibile cu MACSEC. O inovație în ceea ce privește o soluție simplex, în care se poate face un upgrade hitless. Cum se poate face acest lucru? Procesorul suportă mai multe clustere, traficul este distribuit, se face upgrade-ul pe fiecare cluster în parte. Acest lucru este posibil dacă acel network-procesor este capabil și software-ul de asemenea a fost scris pentru așa ceva. Vă așteptăm cu foarte multe demo-uri la booth-ul de demo-uri. Avem pentru Data Center Fabric partea de telemetrie, de NISEC, partea de GPT în cadrul routerului. Acesta a fost ultimul slide și am o singură... aici puteți să vedeți o soluție de data center și dacă aveți 2-3 minute, vă pot prezenta cum funcționează live înregistrarea unui atac live în ceea ce privește un atac de tip multivendor cu amplificare și botnet. Vedeți că atacul vine de la 25.000 de surse, un trafic de 7 giga, deci este un trafic complex, se generează de către traffic generator, atacă routerul din partea dreaptă, trece prin routerul de peering, ajunge și în routerul de acces. Routerul de peering informează prin NetFlow sau prin sample port mirroring soluția de deep field care are contextul de securitate, au peste 6 miliarde de semnături cu diferite surse de problematice de la nivel mondial. Alertează automat partea de Security Operation Center, se creează regulile de mitigare și se instanțează acele filtre pe acel router de peering și se face drop la pachetele respective. Aici, practic, în partea stângă vedeți traficul generat de atacator, în dreapta este traficul primit de către client. Se pornește atacul, imediat apare evenimentul și se creează acele reguli pe care le-ați văzut mai devreme. Regulile respective sunt complexe, vom vedea și practic vedeți că practic în sub 30 de secunde traficul infectat a fost neutralizat și a rămas doar trafic util. Dacă se doresc mai multe informații despre care a fost conținutul acelui trafic, se poate investiga și se pot vedea care sunt caracteristicile. Se vede că atacul a fost de tip multivendor. Unde era aici? Multivector. De tip DNS, bootnet fragmentation și țările de la care au provenit atacul. De exemplu, iar pe fiecare flow în parte se poate de asemenea investiga care a fost sursa atacului și de ce a fost categorisit acel atac ca fiind problematic și de ce a fost blocat. Aici a fost o sursă din Rusia care se știa că este utilizată la așa ceva. Măsurile sunt 15 măsuri care au fost implementate. Unele dintre ele au fost implementate proactiv, pentru că pe lângă filtrele obișnuite de 56 de filtre care au fost pentru a mitiga atacul respectiv, de obicei un astfel de atac cu inteligență artificială va fi urmat de alte tipuri de atacuri și, practic, având aceste reguli proactive instalate, vom vedea cum, în cazul în care vom porni un atac suplimentar, vom vedea cum traficul în partea dreaptă nu mai ajunge la client, pentru că deja regulile au fost proactiv instanțiate. Atât am avut să prezint, vă mulțumesc și aștept întrebări.
Thank you, Lucian. Any questions from the room? Well, I have one.
So last night when I was going to sleep, actually I got a notification that the world record for DDoS attacks has been broken again. 3.8 terabit per second. Just last night, so that gave me quite a few nightmares.
Yeah.
Interesting presentation. At some point you said that DDoS scrubbing center doesn't work, is not effective anymore, and you have to do it at the edge because you always have to invest in more capacity. But isn't that the same thing with the edge? I mean, you have to connect.
You already have the capacity there.
How many people have 3.8 terabit?
You have the router,
Okay.
which is offering the speed and the traffic it's passing by the router, and this router you don't just enable the filtering capability on this router.
But shouldn't you be able to take in all that volume of traffic before the router actually starts processing and diversifying the traffic?
You could also protect in front with other type of DDoS solution.
Okay, like a cloud-based DDoS mitigation
yes.
provider.
Yes.
Like, okay.
Which
Thank
is
you.
complementary, yes.
Yes, like a hybrid solution combining both.
Yes.
Okay, thank you.
You're welcome.
Sure.
Deep field supports also the edge-based mitigation, what Lucian mentioned, but it can also be integrated with, for example, cloud-based DDoS mitigation. So deep field can detect the attack, but then can inform like a third party, like a cloud-based mitigation to actually clean the traffic. So if your peering links are congested, so if you have 100 gig peering links and you have an attack of 120 gig, obviously your peering will not function anymore because all the traffic will go to the router. But the router can signal upstream, or deep field can signal upstream that an attack is ongoing, and the upstream DDoS provider can clean the traffic. Yes, everything is a closed loop. Yeah.
Thank you. Next, we have Josip Duricic from Release 14. Josip, you have the floor. Talking about demystifying lawful interception. You need the mic.
Oh, yeah, or this one. Yeah. Hi, everybody. How are you doing? Yeah, good. It can work that way as well. It's okay. Yeah. So I come from a lovely Croatia, right? Small country. Yeah, beautiful one. Very beautiful seaside and everything else. Thank you. So we specialize. We are a Croatian-based company. Sorry, we are a Croatian-based company. We started. Networks. We started in 2012, basically first as a UK-based company, and then we moved to, all this happened with the UK. They decided to exit the European Union. Might be good, might be bad, but we said, okay, Brexit, and it makes sense for us to stay as a EU company. And what we do, we specialize in lawful intercept and data retention solution. So I don't know, usually when we start talking about lawful intercept, people, starts, pointing the other direction, try to leave the room. Nobody likes to talk about it. But in reality, it is something that is, let's say, mandatory for any ISP to implement, right? So why do you typically, don't like it? Because it's just the cost of the business, right? So you need to implement a solution for the government that they will use to, issue warrants and basically listen in either on the phone calls, data conversations, things like that. And based on that, you have to pay for it normally. In most of the countries, it is just the pure expense of the ISPs. From that perspective, everybody's always worried about the privacy. I must say, the privacy, yes, it's a big factor, but you have to think about as well what you need to really, look and deliver. Usually, and in most cases, there is no return of investment on these type of solutions. As we said, it's just the cost of the business, a regulatory compliance that the government says you must have it, and that is it. And people typically think, okay, this has something to do with the Pegasus. We are not Pegasus. We don't do any man-in-the-middle attacks. We don't decrypt encryption. It's not like that. You know, European Union has very strict laws regarding the privacy in the end. So there is one other thing to mention. It's not a mass surveillance tool, in Europe at least. Some countries like Turkey, Pakistan, UAE, and other Middle East countries, they like to surveil everything. In European Union, as I said, privacy, very, very important. So what is really a lawful intercept, right? So it's just a mean to, let's say I did some crime, and or I'm a person of interest or something like that. The government will want to listen in, maybe tap on my phone calls, on my data communication, and things like that. And then ISP is the one that has to actually have a system in place to be able to deliver this warranty, basically deliver this information directly to the agency. In your case, I think in Romania, this would be an STS. I'm not 100% sure, but I think it's an STS. And when we talk about the data retention, it comes to basically saying, okay, who was behind, let's say in the data communication, who was behind this IP address 6 months ago? It comes basically to that, right? If there is some request coming in, or what was your phone calls, it would be a call detail records basically saying, okay, I was calling this guy, I received calls from this guy, but that is it. You don't store actual communications of data when it comes to data retention. Most countries have it for 6 months to 1 year. In Europe, some countries want to do 3 years, but that's a different story. Legal basis, I won't go much into it. There's a lot to go through. But in Europe and in most countries in the world, ETSI is the rule. Why? Because it's very well documented. It's defined by an ETSI basically regulatory body. And it gives basically some sort of a standard. Because, for example, Kalea, they will say, okay, give us everything you can in whatever format you can. We will try to do it, but it's not so easy. Because there you need to record things and stuff like that. SORM, if we look more, let's say, to the eastern part of the Russia and things like that, it's a bit tricky because it's a fully active method, which means they could actually, if they decide, the whole country cannot call Budapest for some reason, they can block it actually. So it's a fully active method. It's really, really different. Data retention, there is always some fight happening, about the privacy and what needs to be collected between the GDPR and things like that. In Germany, basically, they said they stopped it in, I think, 2014. I think it's mentioned there. They tried to block it, but in the end, every country made their own regulation because in the end, you need to have a logs, right? I think from a local regulatory point, I think ANCOM knows more than we do, but I think it's rule and decision 987 from 2012, actually. And what it basically says is, you need to have this system in place. Will you have it? That's a different story, right? You might risk it, you might not. And you need to bear the cost of such a solution. Sorry, I apologize, it's maybe sugar. I'll skip all this, it's not important. So we know some definitions, let's say. So let's say this is a typical ISP network. There is nothing really typical when it comes to the ISPs, especially the smaller ones. And some of them, deploy MPLS, some of them don't, some move to the VXLAN, stuff like that. But I just want to showcase, from a perspective of this, let's look at the internet service delivery, right? To deliver the service, typically as an ISP, you will have either a PPPoE connection to your subscriber from the BNG, or you're going to have an IPoE, just give them an IP address, or it might be actually aesthetically defined IP. It doesn't really matter. From perspective of what you actually would need to intercept to know this, let's say in the case of the PPPoE connection, you would basically get a copy of your radius traffic logs, basically authentication and accounting, in order to be able to track IP addresses, right? So what your subscriber really has. From that perspective on, you would also need to tap basically either the whole traffic. You would need to tap either the whole traffic. And then, for example, our system or any other system would basically just get a port mirror or a span or a tap. And from that perspective on, they would passively collect all the data necessary, making sure they don't touch anything else except the identified target or a warrant in the end. Or a second approach would be saying, okay, there's an active method. Some systems have it, some routers have it. Like Cisco Juniper, I'm sure probably the Nokia has it as well, Huawei has it, and things like that. You would need a license on the router, and you basically would get only encapsulated traffic of interest. So that's a smart way to do it to ensure privacy. Problem is that you get into a problem of network upgrades, licenses, additional cost. Basically, any traffic usually that hits LI interception point, in that case, in the active one, would switch. That traffic would pass through the CPU, so your latency would increase, and you would really, and in the case of network upgrades, you would actually have to communicate with the governing body, STS or whoever it is in Romania, really, to ask, okay, can we actually do the network upgrade? We need to plan it with you, because if maybe there's a tap on there. So we always prefer a passive approach, even though sometimes the privacy might be a concern. So in an active method, as I said, basically you would need to, is this a laser? Yeah? No? So basically you would have port mirrors of your radius servers delivered basically to the intercept points, and you would tap either this point over here before or after, depending if you have CGNet or not, if it's in the same box or not. And in the active approach, you would just get encapsulated data directly. There is a point of data retention, but I'll try to keep it a bit short. Idea is that in this case, you would need to keep the logs of all of your radius accounting and basically CGNet logs. We do all that as well, so that's not a problem. So, as I said, the purely active, what we say, the active one, it's not really a purely active. It's really a hybrid solution, because still you need to tap some of the parts, if you have email servers and things like that. And radius must be a clean one. This would be a completely passive solution, basically the same thing. Only difference is that you actually really get the whole traffic collected via port mirrors, port spans, taps. So why we always recommend it is just because it's very future-proof. There is no sizing cost, there is no licensing cost, and sometimes it's much easier to deal with the software upgrades or network upgrades. You might switch from one technology to other. You might just start implementing an VPLS, or you might say, okay, we're moving completely to VXLAN or SR or something like that. For the voice, it's basically the same, but the difference is that you need to collect all the SIP and RTP data, deliver it to the probe, and it comes to basically the same thing, right? The difference there is that basically in the standard, and most countries like it that way, they want to see only E164 numbers, right? So if you would collect, so in that case, in most cases, depending on the implementations, this would mean that you can only see the transit. You would not be able to intercept on-call, basically network on-calls, if I call another person on the same network, right? If you would look at basically transit and on-net, you would get a mix of E164 and on-net, and this becomes basically just an issue for the agencies typically, because they still think in, let's say, ISDN way and all these other ways where they just had A number and B number, and in reality, if you think about VoIP and things like that, it can be anything. It's a URI. It's not really there to be a phone number necessarily, even though we all use it and all the ISPs typically implement it as a phone numbers, right? I hope everybody can hear me, and I don't bore you too much. I'll skip this, but basically there is one thing to think about as well. All the smaller ISPs, they typically implement some kind of soft switch that's based on the asterisk. Asterisk was envisioned as a PBX. That's one thing to keep in mind. And second thing is that if you're gonna basically tap it passively, basically you will have two call legs that will not match because they don't use the same call ID. So that's very important to think, whatever vendor you decide on, it's something to tackle as well, because otherwise you will get two calls instead of one. It's something they didn't just implement that way for the B2BA. So as a lawful intercept, it's just basically a black box. There are no interfaces that you can access, only the government can access interfaces. There are some monitoring stuff that you can see, just the traffic throughput and things like that. But even that, in some countries, it's really forbidden. Because that would mean that there is an active intercept happening on the system, right? And here I go back as well to the passive one, saying, okay, in the passive one, you will never know that anybody is under the warrant, right? So some agencies might prefer for the solution to be completely passive. If you have an active one, you could see basically that there is an active interception on the router happening. And in theory, even network engineers could see who it is, really. So, but what about the data retention, right? So, as I said, it's just basically collecting, the CDR, subscriber information, like phone books in reality, netflow IPFix, obviously, the CGNAT records and stuff like that. And what we see, what is definitely happening right now, everybody's moving toward the DPI as well. Already we implemented it in Turkey, but Turkey is more different, right? So what it means is that they will want, besides just your normal logs, basically to know what applications you access, not just what IP addresses you access. So that comes now into, it's a big privacy issue, right? So we'll see if this will really be implemented on EU scale. But what we see at least getting implemented is getting rid of certain traffic of interest. Let's say agencies don't want to, as the speed increases, right? You will have all this Netflix, sending 20 megabits a second, Prime, and everybody's getting all these videos on demands. The reality is agencies are not interested in that traffic. It's legal traffic. They don't care about it. It's just noise, right? White noise for them. So at least in that demand, in that regard, the DPI will be for sure used. So what we say, this is always a bit problematic to implement the data retention, much more problematic than lawful intercept, because everybody has different systems in the backend, right, for the business logic and CRMs and billing systems and all this. So it's very important, to have a proper platform that can make sure that you can easily, just create a new profile, connect to a different system, pull the data out, store it locally, and that is it. Another thing is that EU Digital Evidence Act is coming. It's already been signed by most members of EU. It means basically that any agency, being a police, intelligence agency, or anybody else, can request data directly from any ISP within EU. And this is basically, there is a standard for that, how they can do it, what they can do. But there is always some problems, right? So, for example, some of the countries basically decided that, okay, well, they'll just do translation of the standards, so if you translate, the field names and stuff like that, typically it's not compatible. So you really need to have a solution that can easily tackle such problems. What we do as well, so we do lawful interception and data retention, as I said, so we have Zendified DR. For us, it's just about, defining some parameters, and saying, okay, I don't know, you use free radius. Okay, we have a profile already for that. We can just pull the data out of it if you want. You're using Porta 1 maybe for a soft switch. Okay, we can connect to that. You're maybe using a more soft switch from Austria. Okay, just create a profile on it like this to export the data. And basically, so you have a CGNet. We basically cover all the possible vendors that are out there. Some of them already do merged logs, and like A10, which is very nice feature in reality, simplifies, collecting the data and storing it. So from our perspective, it looks just like something like this. It's all revisions, profiles, different engines that we define, and then, for example, every country that we get in, we create a profile for that agency, like Romania, and every other ISP can just simply use that, and that is it. They just need to change the input profile of the system. So I'll skip all that, because what we hear as well is a lot of ISPs, they try to go into developing the solutions themselves. It's a thing, I don't say it's impossible, but as the speeds are increasing, this is becoming increasingly more difficult, right? So the cost of such a solution development, it's taking a long time, and I'll just skip that. So basically, a lot of the ISPs think they're too small to have any, really requirement for this. The law is the law, right? So there is no question there. The only question is anybody willing to risk the penalty, or is it not? Or they will just say, okay, we're happy to implement it. Normally, the solutions used to be crazy expensive. Most of the companies doing this used to be Israeli companies before, some French companies. We decided to go with a subscription approach, just to provide an easy, pay-as-you-grow model for smaller to medium-sized ISPs that typically don't have a solution for that. We only do that, as I said, we really are monitoring it since 2005, but we are in it really since 2012. Only that, we only focus on that. We make sure that all the new standards are followed. We try to suggest some standards as well. And as I said, some things that we see, DPI is definitely coming. We have customers ranging from, it doesn't really matter, but smaller customers from 55 gigs per second, 60 gigs per second, but we even have really small ones that have only voice and basically do 15 megs per second, which is basically nothing. But we try to, accommodate everybody. One interesting thing to say is that most of the customers as well, the smaller ones especially, when they implement it, they have problems with duplicated data. So some of them, when you look at this, it's like you get 3 packets coming in, 2 packets going out, you need to remove it. For this one, it was a very simple example saying, okay, let's do it, no problem. Just do a MAC filter and that is it. We noticed some serious bugs. We love MikroTik. Everybody loves MikroTik, I guess, but they are a bit buggy. So recently we, noticed a really serious issue with their net logging. So we reported it. So we're waiting for it. Problem is that they're sending duplicate logs. From one perspective, they're not acknowledging the logs as well. So when they send you 3 times create and 1 time delete, you have a problem. You can't match. If it's the same timestamp, it's not a problem. But when it's 3 seconds apart, that becomes an issue. With Israel, with the voice, they have Israel is Israel. We love them, but they also a bit try to be buggy. Their SIP implementation is a bit flawed. But we always try to, for the customer, say, okay, if we can fix it, we'll sort it out until you find a solution with your vendor. The time is running out, so if there are any questions, feel free. Sorry, I've been a bit...
Thank you, Josip. Are there any questions?
Thank you very much for the great presentation. So bottom line, are there any ways to determine whether you are either legally or illegally intercepted?
Generally, no, because this is the problem with the governments, right? They try to close the system as much as possible, right? So, as I said, it's typically really a black box. In Romania, I know if you go to T-Mobile website, they have typically, saying, okay, this many taps have occurred in time and things like that. You have it for Microsoft as well, for example. And you will see in Romania, T-Mobile says, okay, we are not allowed to give this information. First of all, for lawful intercept, they don't know it because, as I said, the system is completely closed off. And for data retention, they don't see any logs. So it's a bit a nightmare.
How about other territories?
Let's put it like this. In Italy, the government pays you for every tap. Okay, so in reality if something is, if how many warrants are there. You don't know still if they're illegal because there's, as I said, there should be a court order always with this, but if we go into that, that's more like government issues. If you're going to trust the government, right? You have to trust it, but...
Thank you.
Yeah.
Any other questions? I have one.
Sure.
Does this apply also to hosting providers? Can it be used?
Yes. Now basically more and more, the hosting and the cloud providers are also now getting into it. There is a bit of a different standard defined for them because right now it's very open to basically say, okay, whatever data you can give us, we want it. Just give it to us. But they go a bit too much into basically saying, okay, in some cases, even for AWS, they're requesting to be decrypted data over there and stuff like that. That's not really good. But I think EU will cover this and basically say, okay, we'll get it sorted.
Okay, because I remember 20 years ago, they were just coming and taking the server with the hard drives, or they were putting it to copy the hard drives. But this may seem a better solution.
I think it's much easier, right, to do it that way. Yeah. But still, in some cases, I'm pretty sure they will have to have a physical evidence as well.
That's true.
There's no question there.
Okay. Thank you, Josip.
Thank you. Thank you, everybody.
Thank you. So we have the coffee break. Moving forward. See you back here in 20 minutes.
Yes. O să scurtăm un pic pauza pentru că am început mai târziu din cauza unor mici probleme tehnice, deci pauza 20 de minute și revenim în sală. Sala de alături poate fi folosită pentru, dacă vreți, o zonă mai liniștită sau să discutați cu cineva. Deci avem și sala de alături care poate fi folosită dacă aveți nevoie de ea.
Session. I understand the craving for the coffee because the previous session was longer than expected. But let's get moving because we need to respect the schedule. So it's my pleasure to introduce Sergei Matashuk from Gîndu with a wonderful presentation named Enrich NetFlow by Metadata. Sergei, please.
Yeah. Hello, everybody. Nice to meet you all here in Bucharest. My name is Sergei Matashuk. I'm a technical consultant at Gîndu Networks. We are basically a company who providing the NetFlow analyzer software. Other than traffic analysis, we're also doing the DDoS detection. But I will try to be quick and will not waste a lot of time because we are slightly behind the schedule anyway. So, I do have some problems with the pilot. Okay, let's go this way. Why do we need to enrich NetFlow by metadata? Yeah, sometimes the network providers do have the task about the application and platform visibility. Why do we need visibility? Because a lot of applications are served through the CDNs, and nowadays more and more traffic each year served from the CDN. Yeah, so it's really nice to have view how much traffic is served from the CDN, monitor CDN, understand where the traffics come from iAccess or from your uplinks, and monitor that traffic and understand how many traffic flowing from which CDN and which application are using that traffic. Okay. Historically, some of ISPs use DPI technology to understand the traffic better, use some layer 7 techniques, and analyze traffic, understand the application, get the statistics, and so on and so forth. However, the more and more traffic get to be encrypted, and Google reports that more than 95% of its traffic is already encrypted with the HTTPS. Right, so it's getting more and more difficult to get the insight about the traffic, and various big companies or big tech like Google or Meta trying to hide that data from the ISPs and consume them by themselves. So we see in that user privacy talks but at the end of the day, the ISP is having less and less information about the traffic that flows through their networks. And nevertheless, you might have DPI solution in place. It might be difficult to analyze encrypted traffic, and it's also costly. Yeah, because traffic grows, and you cannot. Some ISPs cannot afford enlarging or increasing the DPI capacity. So what else? What other methods do we have to understand the traffic patterns in your network? Historically, a lot of ISPs also use NetFlow as a data source to understand what traffic is flowing, where it comes from, where it's going, which protocols are used. So this is the established technique to have the NetFlow, and it is standardized. A lot of vendors support that, and you don't need a lot of CPU power or CPU cycles to analyze the NetFlow, because this is the metadata, and if your traffic increase, a couple of times, it doesn't matter. You need to invest a couple of times more to the software that is doing the NetFlow analysis. NetFlow also may use the sampling technique to reduce the data volume and those reducing the costs, and at the same time providing the compromise between the data visibility and the data amount. So many ISPs already have the NetFlow, but we do have some problems with NetFlow too, because the NetFlow collects only layer 4, layer 3 header fields. It doesn't provide visibility to the traffic. Yeah, and of course, as I said, we do have more and more encrypted traffic, so NetFlow also had these problems. What could be the solution here? Yeah, actually the solution could be enriching NetFlow by metadata. Yeah, and which metadata may we use to enrich the NetFlow? Actually, this is the architecture of the design of the ISP, right? So we do have subscribers here. The subscribers are connected to the NAS device, and then you have your border routers that possibly exports the data flows to the collectors, and then you have apps at the internet, right? So what we can do, we can have the data engine that consumes NetFlow data from the collector and also consumes the control plane traffic from the network sources. Yeah, and by control plane traffic, I mean DNS feed mainly and the AAA traffic. So we might have a parser which consumes the DNS logs or mirror DNS packets from your DNS server, and combine that with the NetFlow data. We do also support having some feeds from the cloud, and then annotate those NetFlow with the data that's received from the control plane or from this parser, store the data and use this annotated data for NetFlow for analysis. So which information can we get from DNS, for example, right? So I do have example here. Let's say there is some application, Skype, in this example, which consumes data from CDN. Usually you will have CNAME for that, download Skype.com host name that points to some host inside the CDN, right? And then this might be another CNAME that pointing to the exact platform that's serving that traffic. And that server has some IP address. And based on that IP address, we might find what is the first DNS lookup from that subscriber. So we might understand what is staying behind that IP address that is stored in our NetFlow data. And using that data, we might understand how much traffic is going from Akamai CDN, how much traffic is consumed by the Skype application or other application. Of course, this is an estimate, but taking into account we do have encryption inside the network, this is the best what we can get from the network perspective using the current flows. So how are we enriching the data using the DNS, right? Our ingester, or you might have your own ingester, listening to the DNS server logs or DNS server mirrored packets, and then analyze and produces the names to IP address mapping for the servers at the internet. And using that data, we understand how much traffic is flowing from each CDN. Talking about the accuracy of that data, I can say that in the real world examples, we might achieve like 90% of data accuracy by volume. So for example, if you do have couple hundred gigabits of data, 90% of that can be annotated using the DNS server feed. Other than that, we might also use the AAA or net data for enrichment. And that allows us to see the end-to-end traffic flow and understand which subscribers consume which OTT services. So for example, you might see that what percentage of your subscriber base are using Netflix, and you might use this data or these reports to better position your own IPTV service, right? Or maybe you will be able to make a special proposal for those customers who are using the Netflix from over the top to your subscribers. We may also use different data sources from the cloud. And this is the GeoDB, of course, to understand which countries are sending the traffic or which AS numbers are you communicating with. And then use those data for developing your peering policy, for example. I would also like you to point to some case study. We did this POC at the ISP, some Asian ISP, which have more than 10 million subscribers. And they have around 450,000 flows per second at 1 to 1,000 sampling rate. And the control plane traffic is about 60,000 packets per second. So as I showed you at the previous slide, we are collecting net flow from the border routers, and then using the net flow collectors for that, we're also collecting the control plane traffic, combining that, and the flows are getting annotated here at the data engine. So then those flows might be stored at the database, and you might use your ad hoc queries later to understand what was the data that flows through the network, right? In that particular example, we also exporting the annotated flows to the ISP's Kafka cluster. So those flows are used later for business analysis using the existing ISP tools. Yeah, so enriched flows are stored there for like half a year, and depending on the sampling rate you would like to have, it might consume a lot of storage resources, right? But it's up to you. It's up to your decision. How long would you like to store this data? Yeah. Any conclusion? Yeah. So as I said, most of the internet traffic is encrypted, and passive DPI have some troubles analyzing the traffic and detecting the exact application that are used. We do have some alternative like NetFlow, which is more cost-effective and also might have some 90% accuracy. By enriching NetFlow with DNS, we can still maintain some application visibility and understand which CDNs serve traffic for those applications. Enriching NetFlow with AAA data feed, we might understand end-to-end traffic flow and might identify the subscribers that are using over-the-top services to better position our own services. And enriching NetFlow with the other external data, we might have better traffic visibility in, let's say, other dimensions. Yeah, and this might be useful for operating analysis. You might have some questions by that presentation, and I will be happy to address them at our table, which is located in the hall. So you are more than welcome to come there and have further discussion about that topic. But most frequently we do have this question, is it mandatory to mirror DNS and AAA packets. Yeah, the mirror of those packets is good, but logs are also might be consumed, right? So you don't need to mirror the packets if you don't have this ability. You might just send the logs of those servers, DNS server, and we will analyze those logs. CDN servers might serve many applications, right? And behind one IP address of the CDN server, many applications may be hidden, or many websites may be hidden. So how about the accuracy of detecting which applications are served by that particular server? Yeah, and we do this by so-called accurate TNS, when we match not only by the IP address of the server, but the IP address of the client who's doing the request. So for example, if DNS name resolves to the multiple DNS names resolves to the same IP address at the cloud, we might use the subscriber IP address to distinguish whose subscriber is accessing which service, and then approximate the flow data using that ratio. One might ask, can NetFlow monitor the application performance? Yeah, and unfortunately, NetFlow cannot be used to monitor the application performance, and I believe there are more suitable tools for that, but we may measure the flow amount, yeah, or the amount of data that traversed between the customers and the application servers. Next question is about the legal aspect to DNS and AAA packet sniffing. Yeah, and one might think if it's legal to sniff these packets. And the answer is you may sniff or use the data as long as you sniff your own DNS server packets. So there might some question arise when you sniff in all the internet traffic from the particular subscriber, but using your DNS server logs is pretty straightforward and legal. Another question could be about the flow records with DNS and AAA is very sensitive, so you might deal with some privacy concerns and how to protect that, how to protect user privacy. And we do have answer for that because you might use, or our system might use, tags or anonymized data to not store the particular subscriber name or personal information. Yeah, and that's it from my side. I will be happy to answer any questions.
Thank you, Siarhei, very much.
Thank you.
Especially for keeping it very short and helping us getting back into the schedule. I would be happy also to encourage the hall to address questions. Please.
Yeah, my name is Oleg. I am from NOKIA. And we also have a same product like a flow analyzer. And I have two questions here. When you parse a flow, do you store only some kind of fields like IP addresses in out octets and that's all, or you can store more than that, or somehow to check what the user can store or not store, or something like that? Yeah. What information do you need for analysis of this? And this is one question, and another about the data granularity. Do you store by each minute, every 5 minutes, or you can aggregate, something like that? Thanks.
Yeah, thank you. It's a really good question. And the short answer is this is configurable. So you might configure which flows to store or which fields to store in the raw data. Yeah, because we do support, of course, raw data storage. You may also resample that before storing. So you might also have different time series. So for example, for the last week, you might store like 1 minute interval. For last month, you might want to store 1 hour interval. And for last year, you might want to store aggregated data for, let's say, 1 hour, right? So it depends on your need. We do support flow aggregation, and we do support also storing different information. So for example, if you don't need the port numbers, we might not store that to save the storage resources.
Thank you. Other questions? None? Then thank you again, Sergey.
Yeah, thank you.
And keep in mind, you can find Sergey for further discussions in the next hall. Now, Ben Cartwright-Cox, BGP Tools. Ben, please get the mic and proceed with route collecting on Interland with BGP Tools. Thank you.
Do the slide wiggle. All right, okay. Hello, everybody. I am Ben Curry-Cox, and I'm going to talk to you today. Do that so talking today about BGP tools and sort of what route collecting is in general. So a quick overview of BGP tools if you don't know what BGP tools is. BGP tools is effectively a website that you can go to look at other bits of the internet focused on, focused on sort of looking at what other ISPs are doing in a sort of like BGP table universe. So you can basically look up ISPs, see what prefixes they have, for example, and a bunch of other stuff, which I'll get onto in a second. The core point is it was built out of frustration that I had with other tools. Running it is now my job. Feeding the system is about 2,000 BGP sessions. Using those 2,000 BGP sessions, data is basically updated in real time. And then for data that I can't update in real time, things like DNS, generally speaking, within 2 weeks, the site refreshes all its data. Also, a whole bunch of, because I've been on the operating end of networks, a whole bunch of stuff which I would consider quality of life features have been sort of focused on quite a lot, including things like making sure that IXP data is very carefully processed and data looks sane before importing. One of my core bugbears is making sure that things like propagation diagrams work correctly. For example, this is a propagation diagram for just a random prefix. I think this is a digi prefix, actually. And so you can see their propagation outwards to tier 1 providers, but also you can see stuff going out to internet exchange root servers. So the other cool thing the BGP tools does is it can make you look at upstreams. Also, you can either look at upstreams on a per prefix level, or you can look at it on a whole autonomous system level, on a whole AS level. The upside of this feature, or downside potentially, is this thing is really good at finding root leaks. So we look at the bottom of Digi's ASN, you can see 2 relatively suspicious ASNs that don't quite look right. So for this, we can push the little WTF button. It's called WTF because it's the button that you click when you go WTF. So that gives you effectively a reasoning, sort of list of why BGP tools thinks that. I should make clear that this button is unfortunately only a paid function, but we'll get into that later. But once you can click that, you can see the prefixes that it thinks that it's doing that. And yeah, on the prefix diagram, you can see that looks relatively suspicious, looks relatively unintentional, probably some static prefix lists that have gotten a little bit out of hand there. As I said, BGP tools offers paid monitoring services. So if you are interested in sort of having real-time updates from the website sent directly to your phone, Slack, whatever, then you can pay BGP tools. This funds the upkeep of the site and funds me to continue working on it. If you want a more sort of raw traditional experience, the site also just operates a standard looking glass where you can throw in a prefix and it will give you all of the data it knows about that prefix. All the paths, all the communities and stuff like that. It'll also make a bit of an effort to try and decode what those communities actually mean, something that makes a huge quality of life difference if you're trying to do, let's say, traffic engineering, or trying to figure out why you're not getting a prefix and other people are. And as mentioned previously, I also put a lot of effort in terms of internet exchange points. So this is the internet exchange point page for Interland, and lists, I think, some pretty interesting information, including what vendor people are using, or guess based on the MAC address, whether they are actually online, which is very useful to figure out if they've actually arrived at the IXP yet, what they are announcing to root servers, if anything, And critically, is their equipment accidentally sending data out to the sort of broadcast domain that they shouldn't be? So think things like sending OSPF into a peering LAN, stuff that you should never do, but mistakes do happen. So this data is combined from things like PeeringDB, but it also takes in, if available, the IX's direct data through IXF. And then on top of that, if I have presence on that exchange, then I will use the root server data to try and discover peers that are not on those exchanges, are not visible in other bits of data. So it's also quite good at finding ASNs that don't necessarily want to be public. So what is a root collector? What is the thing that powers the core of this? So a root collector is basically a BGP peer that has a little bit of extra software and configuration to record BGP routes that you send it. So critically speaking, a root collector does not use the routes that you send to it to send traffic to you. So if you announce a full table to me, I will not use that table. I will only take the data from that table and put it into the rest of the storage engine. Sometimes, in the case of RIPE, who also run a root collector, will announce prefixes to you for transit and peers over. So you ideally want to export the full, what's the current internet DFC, like 1 million routes and 200,000 routes for IPv6. So you want to ideally send the full table. This is very helpful for many things. So because the internet is a network of networks, it's very hard to see what other people, when you send a route out, obviously you don't know what the internet sees from you because BGP has no feedback mechanism on whether someone has accepted something from you. So root collectors are useful for your own need to go and see if people are accepting your routes or filtering you out or doing something like that. But they also fill a very critical role in research. It turns out the academics sometimes write relatively insane and wild papers that are basically due to bad data, or lacking of data in certain regions. So whenever you see people or academics make relatively wild claims about a region that are not right, that might be because they're operating on very limited data. So for example, the one example of this working successfully is the February 2008 incident where Pakistan leaked their censorship of YouTube to the rest of the internet. That incident would have not been anywhere near as well understood without root collectors recording that data at the time. So if you do want to provide data to such a system, doing this is very easy. You just go to this link, or alternatively just scroll to the bottom of BGP tools and look for the little contribute data icon. You can log in with a PeeringDB account, or if you don't have one of those, you can register for a full account on BGP tools, add contact details so I can email you if something goes horribly wrong, fill out a new session form, and sessions are instantaneously provisioned. You can provision this over an internet exchange where we are both present, or you can do it over the internet. You can also control how this data is used. So there are 3 checkboxes here. One controls basically if other people can see the data or not, if you want to appear in the public looking glass, or you want to have your data used by academics. The other includes whether people, third-party commercial entities, are allowed to receive this data from BGP tools. Think like if a competitor service or even just a generic data harvesting service wants to receive that data, they have a separate license agreement, so you can choose not to be included in that data set. And then finally, whether I should tell you if the session is down or not for more than 2 hours. So what's in it for you if you feed it? Obviously for the good of the internet, of course, but that's not always the best argument. So rankings or better numbers. So obviously there's a connectivity tab on BGP tools. It lists your peers. BGP tools cannot know the peers you have if it doesn't see those AS paths. So if you feed BGP tools, the number gets bigger. Also, as I mentioned, I have rankings based on these things. So you have here, the list is this ASM, which I won't mention what it is because I don't know what it is actually, is number 95 for known global peers. Obviously, this is a very fluffy metric because it's entirely controlled on who feeds data to BGP tools, but you can get a higher number, and sometimes customers and prospects like a higher number. They think it's a better network. In this, if you're curious, this is the current, or maybe as of a few days ago, rankings for Romania. This is sorted by AS cone, so this is about downstream customers. You'll also notice that Turk Telecom is not a Romanian network. This is because Turk Telecom is registered in Romania, and locating ASNs by their registered country is kind of difficult. This is the sort of global problem with the internet. You have large ASNs, like for example in Europe, you have Liberty Global, which operates in several countries under one ASN. This ASN is technically Austrian. It's a little bit of chaos. The ranking system operates on a few different things. So you have adjacencies, which is the peering rank, which is the one that you can realistically change if you feed data. The AS cone, which is basically how many networks you have underneath you. There's an estimated eyeball system, which is a little bit of magic. And so we'll never tell you the raw numbers. It will just give you a ranking. Unique domains hosted, which basically would let you rank how big a hosting provider is potentially. And then finally, just how much IP space are you originating? And no, this is what I was talking about beforehand. So if you decide to opt in to have your data visible, you can also point people to your BGP tools page and have BGP tools act as your looking glass. So you might not need to maintain one. What about other root collectors? So I hinted at other root collectors existing. Other root collectors are available. There is RipeRIS, as previously mentioned. They are not instant. Most of these do not offer instant sign-up. You have to fill in a form and may or may not get back to you. But RipeRIS is ostensibly accepting sessions. That it's not accepting new sessions right now is wrong. I apologize. So you can, I recommend feeding all of them because it's useful to everybody to have as many of these copies of data as possible. So there's RipeRIS. There is a University of Oregon in the US project called RootViews, who are also doing similar work. There's me, of course, and then there is Curator Radar, who has instant sign up as well, but they don't do our Internet Exchange Point collection. Here's some breakdown. So if you're only on Interlan, you have two options for root collection on the IX, which is RipeRIS and BGP tools. Are there any questions? And thank you.
Well, let's give a big hand to Ben. Questions? Anybody? Come on, it was a great presentation, a great work. Thank you, Ben.
You can find me in the corridor if not.
Okay, Ben, I actually have two questions. One, as everybody knows, I think the BGP send the best routes only, yeah? And you should collect all the routes. So in this case, as requirement to enable additional path capability in this case?
So I do support additional path or add path. You can do it. My side doesn't really care. If you present the capability on your end, I will just instantly accept it. That add path is supported. There's two ways of thinking about that. So there's a downside for add path. I would still point out that I would appreciate people to enable add path because it gives me more data. But there is a downside to add path in that because it sends you all of the paths, and because routers have different selection logic, which is invisible to me once you start sending add path, I don't know which route that you prefer, which in itself slightly decreases my view of a network in that, you may have 4 transit providers, but sometimes the interesting bit is which transit provider are you using to get to that place? And if I have no metrics with add path, then I can't know. So there's upsides and downsides, but it's mostly upside.
Yeah.
What was the other question?
Thank you. And second question, have you ever analyzed the possibility to have BMP as a source of data?
Yeah, BMP is a really interesting one as well. It's a slightly more complicated protocol. And so I have a working BMP implementation. So if you're interested in that, please email me. There's going to be some disclaimers around vendor support. There are a number of vendors that have pretty scary BMP bugs, which is the reason why I haven't advertised its existence is because what I don't want to happen, one of my key points with this entire project is that I do not want to harm any network. And BMP right now, for quite a lot of the vendor software that they're actually running, that is not necessarily the latest version, if you enable BMP and the session does something bad, if a connection interruption happens, there is a non-zero chance that the entire routing daemon crashes, which is kind of an unacceptable risk to present on ISPs, because obviously your routing daemon crashes is itself an incident. So it's just not okay. And so if you're willing to accept that risk, or basically I'll ask you what software you're running and I'll say yes or no.
Okay, thanks.
There's a question down there.
Whoa, good.
Hi, thank you for presentation. My question is, do you support only direct BGP peering or maybe multi-hop or some tunnels, GRE tunnels or something like this?
Yeah, so I support IX peering and I also support multi-hop. I I'm indifferent on which one. I would sort of more lean towards multi-hop peering being nicer, as it means that if for some reason I'm no longer able to get to those IXPs, I can still keep the session up. But whatever works best for people. Obviously, the reason why I'm on the internet exchanges in the first place, I built the original empire out of multi-hop sessions, but there is limits to what people allow on ACLs. So sometimes multi-hop is not an option. And so for that, internet exchange.
Yeah. Okay. Thank you.
Anything else? If no, that thank you again, Ben.
Thank you very much.
And we should call for Livio Morina to show us what's new on PeeringDB. It's better to use this one. Yes, this one. How's the flight?
Are the slides here or today?
Yes, I have a B1 in Romanian, but what is the start presentation projectare?
Downstairs you have a button on the right side.
Yes.
A small,
Okay. I prefer the shell, but yes,
yes.
This one?
Yes.
Perfect. So, it was hard, but I'm here since I don't know if you heard that yesterday in Italy an airport was closed from 8 a.m. to 8 p.m. with 250 flights cancelled. My one was one of those flights, so my travel was disrupted. But I'm here, so now let me go ahead. Is there anyone that never heard PeeringDB here in the room? Okay, so we can go a bit faster on the introduction. PeeringDB is an association based in the States that is useful and helpful for operators, for all the companies involved in the internet business or colocation business, because it is a database that helps to find a data center, a network, and to optimize the network of an operator, if you're running an operator, for example. It is a no-profit, so it is 100% sustained by the sponsor that I will show you at the end. And on PeeringDB, you can find different objects, not only network, but also facilities, internet exchange, carriers, and so on. Having a PeeringDB record is essential today because if you have a network, if you have an AS number, and you are not on PeeringDB, the big CDNs will not establish a peer with you because they use automation acquiring data from PeeringDB. And if you don't keep the PeeringDB record updated, you will not be able to establish this session. So your traffic will not be optimized. Also, if you are in an exchange where that provider is present, but you will use the IP transit to receive some routes. So it is better that you always keep an eye on PeeringDB when you modify something in your network. Why you should be on PeeringDB? For a network, I told you, this is the point. If you're not there, you are missing a part of the traffic, of the best path of the traffic. But also if you have a data center, or you are a carrier, and you're not showing on PeeringDB what you have, so your facilities. Oh, yes, I'm Italian, and I want to come here in Bucharest. But if I don't know the market, what is my first choice? I go on PeeringDB, I check what is available on PeeringDB, and probably I will start sending emails to the contacts I will find on PeeringDB. If you have a data center that are not available there, maybe you're not interested to get more new customer and more customers. So it is okay. You can go with that. Otherwise, it's better that you can you go ahead and fill all the data about your data center. PeeringDB is made by volunteers. I'm a volunteer, and oh yes, I didn't introduce myself. I'm in the board of PeeringDB, so I'm a board member, elected board member. I'm also member of the outreach committee, and I'm here to to do also this task with you. And I'm running an ISP in Italy, so I'm an ISP like a lot of us here. And I am I'm a board member of the Italian Association of the ISPs. As I told you, PNDB is a voluntary organization based on the sponsorship. It is based in Seattle, so in the States, and it is 100% funded by the sponsor. These are the board member with me. Shona is the secretary, and the other guys are the other members of the board. We don't have only the board. The board is only like in the companies. So we are checking the political stuff. We are deciding the reasons to modify something in the bylaw and something not so exciting for technicians. But we also have a lot of committees. These committees are the heart of PNDB. All the committees are formed by volunteers. So anyone can join, can send an email and try to help the project to increase the quality, increase the time for the answer to the ticket, and so on. The admin committee is the committee that is answering to your tickets. All the tickets you are filling in the support portal will be managed by the admin committee. The operation committee is the one that is managing where to do the purchases, what to optimize with the costs, and so on. The outreach committee is the one that is managing the marketing, the presentation, and all the related stuff. And the product committee is the heart of PNDB, where the decisions are taken about the develop of the product. And the develop is not decided by the product committee, and that's all. All the users, so all of you, can join the GitHub record, GitHub page, and fill your ideas. I'd like to have this function in PNDB. Most welcome. You can fill your details, the details about your request. Be as you have to fill a lot of details because other people need to understand what are you saying. So they will put the thumbs up and say, "Oh, great idea, great idea." If the consensus is reached, the product committee will check the request and will see if the request can be implemented because yes, it could be a great future, but if that future will break all the database, all the other functions that we have, so it could be a problem. It could need a lot of hours to be developed. The developers of PNDB, the project manager, is one of the paid person in the PNDB because he's doing this for business. It is not a volunteer like us. Just to tell you how to be a member and how to vote in PNDB, all the users on PNDB are free. You don't need to register, you don't need to pay. You just go on PNDB and you do whatever you want. If you want to become a member, you just have to be a user, registered user. So you should have a data center, a network, so a reason to be on PNDB, and you can be a member. Say that you can also decide to vote for the board and to contribute in other ways sometimes. And to do that, you just have to be a member and subscribe to the government mailing list. Once you do that, you are fully entitled to vote for PNDB. There will be the election. There are the election every year around May for the board renovation. So if you want to take a look, there is a nice tutorial on the website, in the documentation website, and you will find a lot of details about how to do that. PNDB is a website, but you can also access to the data through the APIs. So you can create an interface with your tools, and you can optimize your tools using updated data from PNDB. So this is the way that Fastly, Meta, and so on are doing that. So they are collecting data when they need, or also every day in base of the need that they have. And then with the APIs, there is no limit. So you have just to do it in the right way. So don't hammer our databases, because the more queries, the more invoices we receive, and so on. So there are best practices that we will share with you if you want to to go deeper in this function, but it is possible. So if you need to start, there are the documentations available. Otherwise, you can send an email to the support email, and we will guide you to develop what you want. This is the workflow that the product development workflow. I told you that GitHub is the base from where all the requests are coming. Anyone can do that, can fill a future request, can contribute also filling comments to other future requests. It's a community, so the consensus is granted by you and us. And the product committee check the request, and if it is good, we implement the request, and it will be present in one of the following releases. The releases are made every month. So once a month, we release a beta. The beta will be available for 1 week. So we encourage you to use the beta because it happened also last year that we released the beta and we didn't have enough debug of it. And once released, it was a mess. So we had to do a rollback and go back. So if you can, we invite you to use the beta version. You just have to replace www with beta and you will be there. The only difference from the main version is that the beta is not live updated, but it is updated once an hour. So it is a bit different. So if you need to interact with the APIs and so on, you use the main one. But if you want to browse with your laptop, you can go ahead with the beta. We will be happy that you will do that. We have a new UI design, and if you have tested this new design and you have an issue, please report it. We are fixing some box that is in the wrong place, some box that is too wide, too small. Yes, it is only using the service that we understand what is needed to be modified. We are also, this one here that we introduced the KMZ of all the data centers available. So you can download one single file with all the knowledge of the facilities of PeeringDB. We will introduce also something is already available, but not fully available. We will introduce also localized KMZ. At the moment, the KMZ is available at the bottom of the website, and you can download the full database. But let's say that if you are searching for a Romanian facility, and you have to download the word of the facilities, that it could be also heavy to manage if you don't have a laptop or a workstation that is up to date. We also improved the search because we had some issue once we decided, or the community decided to introduce the natural language that is not so predictable. And we are also always available to acquire requests to participate as volunteer in our project. We are also working on better device presentation, dashboard options to make faster to find something, and also to optimize the loading of the page that someone reported. This is the KMZ that you can import in your Google Earth, for example. The search, yes, we can go ahead. Beta tester, done. Admin committee. The admin committee is the committee that is answering to the tickets. In this case, in Europe, we are covered by a lot of different members that are helping in this committee. But since we want to answer as fast as we can, we are searching new volunteers in different regions. So in Asia, we are missing data on PeeringDB because a lot of networks are not available, but also volunteers because sometimes someone from Asia is submitting tickets, but for time zones, the ticket is taking longer than a ticket opened here in working days, in working hours in Europe or States. So if you have time, yes, you can submit you can answer to my call for volunteers, but we can talk about that. I'm here all day long and also at the social. Just to tell you the growth of PeeringDB, this is updated to the half of 2024. Yes, all the facilities, IXs, and the networks are increasing. I don't see the. Are you able to see the colors? Yes, here is easier to see. The IXs are pretty the same. The users are increasing. The organization are increasing, more networks, and so on. So it is working. But I want to finish showing you something more detailed on you. This is the point of view of PeerDB on Romania and the neighbors of Romania. I think that the slide will be available, so you'll be able to check all the details. I want to tell you on the Romanian line and to explain what is the name of every column. The first one is the number of the IXPs and the number of the owner of the IXPs. So in this case, in Romania, from our point of view, then I don't know if it is real and someone is missing, but there are 9 internet exchanges owned by 9 different organizations. There are 164 ASN, and these are the ASN that are available in these 9 internet exchanges, okay? And in these 9 internet exchanges, there are only 89 ASN that are Romanian ASN. How we check the nationality? We check on the RIRS to understand if the ASN is registered to an European company in Romania and so on. There are also 41 facilities run by 31 operators. So there are operators that are running more than one facility. In these facilities, there are 150 ASN globally, not located only in Romania, not originated in Romania. And 74 of these ASNs are Romanian. The total is that in the IXPs and in the colo, there are 270 different exchanges. So we are not counting twice a network that is available in the exchange and also in the colo. We do the diff, and there are 217 total IS numbers and only 104 that are Romanian AS numbers. So that PeerDB have 168 AS numbers from Romania. So some of this AS number is not present in a facility or in exchange. And checking the RIRS, is this data correct? I should check. Showing from this data, you should have 1,125 ASNs in Romania. Could be right. So only 15% of the AS numbers available in Romania are registered on PeerDB. Yes, a lot of data are missing. If you are checking the other countries, there is Hungary with a lot of 1 on 4 are available, and you're similar to Moldova, and also Serbia has a similar percentage. Ukraine has a higher percentage. You can take a look and see what to do. We can increase the quality of the data, because if we miss the AS numbers, all the users that are using PeerDB are missing a part of the view. So they cannot take a decision seeing all the opportunity that a market can provide. As I told you, we are sustained by sponsors. These are our sponsors. I saw that someone is also supporting Ronog, such as Digital Realty and Interland. You can see them in the slide. But also here, checking the faces, I saw that Telepoint is here. That is another of our sponsors that is also attending this event, so from Bulgaria. And I saw also NetNode from Stockholm, Sweden, that is here. They're all sustaining the community, sponsoring PeerDB. And so with the money that we collect from the sponsor, we are able to pay the invoices for the clouds, to pay the project manager, and so on. And I'm not getting €1 to be here, so I'm totally paying for my travel, for my hotel. I'm not getting money from PeerDB. I am just a volunteer, and I like to do that. Thank you.
Questions? Yeah, questions? Everything clear? Oops.
Thank you. I have actually a few comments. I can tell you why there are 9 out of 9 exchanges in Romania, so 9 owners and 9 exchanges, because usually in Romania the exchanges are distributed, because Bucharest is acting like a central hub for the whole country, and the point of presence are just local point of presence of the same exchange. So they are not local exchanges, they are the same with, they are distributed. And the second comment, you didn't mention anything about translation, but I know why, because the Romanian version is is the single version which is translated 100%. So there's no need to say anything about translation because it's fully completed here in Romania.
Yes, but since we are updating the tools available on PNDB, sometimes new files are rising. So if you are developing the translation, keep an eye, I don't say every day, but keep an eye that sometimes the 100 could become also 99.9, so it requires a bit of effort, okay?
But now it's 100
yes,
today.
Yes.
Okay, thanks.
Any other question? Italian to Italian, let's see.
Ciao Livio. Riccardo, RPKI. I checked the number and yeah, it's 1120 cents for Romania.
It's correct. Yes, because Arnold sent me the data and didn't check, but when Arnold said that, I trust him.
Okay, any more questions? No? Then thank you very much,
you.
Livio. Now let's see Oleg Makuletsky with geo-blocking in BGP.
Okay, hello everybody. Let me present fully once again. My name is Oleg. I am a support engineer at NOKIA. I have been working at NOKIA for 4 years. So my topics or my target for today presentation is to talk about the geo-blocking and share my knowledge and knowledge that I can collect my experience as a support for the different customer requests to blocking something, due to different reasons. It's a low reason or maybe it's internal imposed by security team. So let's go. So this is 2 worlds, geo-blocking. Let's discuss about this, these 2. First of all, what mean the geo? That mean we can somehow, based on the open source database, for some database we pay. Some database is open source, some databases should be pay. So we use this database to get the geodata from there to understand from which country, from which city the traffic comes in, or it's a part to which prefix. So about the blocking, why need to block something inside your network? So block to different sources to access your network. This basically is a customer request to block some traffic that imposes by law in their country, or this needed due to some malicious activity, like the DOS attacks and so on. So it's faster to block the initial sources or initial country from which attack comes in. So this, as I described here, is some diagrams. We can see that Russia have, due to sanctioned by most of the countries, and impose it this section. It's kindly most of our customers wants to block the traffic comes from Russian resources. So here's DDoS attacks by numbers. You can see in 2023, based on f5.com, it's increased a lot. So target, DDoS attack number in geography. This is a target. This is the United States, second with France. What state is mostly under the attack? Yeah, because in the United States, as everybody knows, a lot of the resources, mainly 90% of all the resources is located in the United States. So here you can see the number of top countries and region hosting DDoS bots from which country. Yeah, it's the attacks come in. You can see the 33% from China. So here let's discuss firstly about how we can mitigate or how we can handle to block something. Yeah, we can use embedded BGP communities. It's called it as a traffic engineering. Each provider, each tier 1 ESPs has this type of communities implemented already in their route policies. So you can use it, and you can add these tags, these communities to your advertise, and you can block based on this. Yeah, based on these tags, because the tier 1's tags on their side, that some prefixes comes from different countries. Okay, basically, this is the second method. It's for my experience, yeah, it's most the method that can cover all your needs. Yeah, in this case, if you relay only the community that it's implemented or not on tier 1 side, on BGP communities here, you can create it and block from your side, yeah, all the unneeded sources using the flow spec. Maybe somebody doesn't know what is flow spec, yeah. So let me give you some details about this. BGP loves to have a lot of families, yeah, and handle everything under the family. So it's develop the IPv4, IPv6 families, and under these families, it's also developed the flow spec families, or like subsequently families of IPv4, IPv6 that can be enabled on the router side. So, and it can receive from the different sources the flow spec rules, applied it, and it's applied it immediately and reacted on the proactive. And you can, like in a few seconds, block everything, yeah, after they announce this flow spec rules. So here presented how you can set up the flow spec controller. Here there's a lot of stuff work where you need to, like, I place here the Bermuda, yeah, the region or a country. So need to do all this stuff, and the results. This is output from. This is on. This is output from the Juniper router, so how its sources is added, and here you can see the 0 matches, because here it's matches by the source. Yeah, nothing comes from there. Yeah. So this route maps all done on a Cisco, but its outputs I send the rules to the. I use a Cisco as a flow spec rules generator, and the Juniper as interpreter here. So here's about the accuracy. like I said before, this about the max mine, DBIP, AP2 location. You see that everything gets increased. Yeah, for this reason. And here the screenshot for our platform, how it's look like. 1-2 clicks, you can add here under the flow spec policy, here under the flow specs policy add, put the country. Here you can see that it can be created the rule more granularly under the different ports, protocols, and so on. Here you can see the affected prefixes that we can take from the GeoDB database. And also, yeah, like a SICA, you type a country. Here you can add everything like a protocol, UDP, ICMPs, and so on. Just by 1-2 clicks. Here, the most important, it's unpacked the previous Angola country, and Angola identified 280 prefixes, both IPv4, IPv6, both of them. So, well. So here is a present that you can exclude something if you don't need it from the unpacked list, and so that's all for today.
Thank you, Oleg.
Yeah, if you have some question, please.
Questions? Who wants to filter some
please.
traffic?
Hello, my name is Eugenio. So you are collecting the geolocation data from different databases.
Yeah.
I understand. Sometimes, so mostly the different databases have the different geolocation for some IPs,
Yeah.
so for some prefixes. How you handle it? So you block the IP or you block the region if it is in the different regions on databases.
We block everything that's unpacked under this region from the database. Is something wrong? It's how we can handle this. We introduce this exempt tab. We can remove the prefixes from there.
Yeah, but you can see the data that you collect from different databases. So which the prefix is from different regions or not?
From which databases we collected it? No,
you can see.
It's something. It's related. It's compare inside. It's some intersects or not. Yeah, it's available or not there.
Okay, thank you.
Any other question? If not, then I propose you a new filter. Let's filter out all the packets from this room and take the route to the lunch.
Yeah, thank you.
Thank you, Oleg.
We would like to thank the sponsor for the lunch is NOKIA. So enjoy the networking lunch.
Thank you for the filter.
improvements in their equipment on recent news, and it's very interesting because all of us, I think, use such devices, such technology.
Hello, everyone. On today's session, we will focus on transceiver and technology behind. Because with the historical approach to the transceiver, we find out that we have some limitation which we are not able to overcome because of we are not able to change the light so frequently to get the bit rate we need now. And because of those, we face a lot of interoperability issue on the optical side between 100G, 400G, and 800G transceiver. And we will try to look into the technologies behind to help you understand which transceiver could be connected to which one and which one will be able to connect into the future generation of transceiver which come into the market. So to cover that topic, we will take a closer look to the technology behind, which is PAM2, which is maybe better known as NRZ, non-return zero modulation. Then we will have a closer look to PAM4 modulation, which is able to carry a bit more data. And at the end, we will talk about the coherent modulation, so the one which not only gives us speed, but also is able to give us distance because they have very powerful DSP inside.
So starting to the oldest way of signal modulation used in popular transceivers, we will start from, as Marcin mentioned, NRZ, on-off keying, just two levels of the signal amplitude with respectively attached to logical values 0 and 1. In each cycle, we send just one bit of information using this type of modulation. With the rising the transmission speeds, we have significant decrease of the range of the transmission. With 1G generation of the transceivers, we are able to reach even 200 kilometers. With 10G, it's already only 80 kilometers. And with 25 gigabits per second, we have 40 kilometers as a nominal maximum range. 100G in most popular transceivers is also have the same range, because in 100G transceivers, as we will show, we use also for 25G optical lanes.
The very important is that with the NRZ or PAM2 modulation is the only one when the bit rate is the same as a baud rate. So in fact, previously, we even do not distinguish these two words. What is the difference between them? And this is something which will appear in the PAM4 modulation, that the baud rate, in fact, is different than the bit rate. The baud rate is something what is how frequently we will change the light state. And the bit rate is effective data we are able to carry over the transceiver. So we do not talk about this with the NRZ or PAM2 modulation, because bit rate was equal to baud rate. So we just use the one sentence. When we talk about the transceiver equipped with that technology, and 100G transceiver is all popular transceiver every one of us know. So first of the example is CWDM4. The name of this transceiver comes from the CWDM wavelengths this transceiver are using. 1270, 1290, 1310 and 1330. So this is the wavelengths behind, and this transceiver allows us to make the distance around 2 kilometers. And the other four are using a different wavelengths. So they're using the wavelengths called LAN-WDM. So these wavelengths are more concentrated around the 1310 wavelengths. The distance is already not 20 nanometer, but it's around 5 nanometer. And all is necessary to achieve a bit longer distances because we operate in O-band. And most popular fiber in the world is G652. And those fiber have the zero compensation around 1310 wavelengths, zero chromatic dispersion. So because of those, we are able to achieve the longer distances. What is very important, there are some things in terms of the connection this transceiver together. So when we talk about the CWDM transceiver, the CWDM4, we are not able to connect them to any of other 4 I was listed. So this transceiver we operate only between the other CWDM4. All other LR4, extended LR4, ER4 or ZR4, they are able to operate each other. Only what we need to take into account is how the receiver of the transceiver is constructed, because we could overload the receiver. And just to avoid that, the receiver which are installed in ER4 or ZR4 could be overloaded. That's why we should do not connect it directly, making the optical loopback. So the safest way is to use a 7 dB attenuator to do that. And most of those transceivers come with 2 hardware versions. One version is single rate, so they support only Ethernet, and the other is dual rate, which support both Ethernet and OTN, OTU4. So this is the important to take out after this 100G transceiver.
So let's leave behind those transceivers based on NRZ modulation, where we have 4 lasers multiplexed to one transmission line. And next possible modulation way is PAM4. It's also modulation of the amplitude of the transmitted signal. However, we don't just turn it on, turn it off, as in NRZ00 key modulation, but we use 4 levels of intensity of the light we transmit. And thanks to that, we are able to distinguish 4 levels of the signal amplitude and attach to each of these level 2 bits, 2 logical values instead of 1 in like in NRZ modulation. Thanks to that, in one cycle, we send not 1 but 2 bits, and it gives us doubled throughput in comparison to NRZ. Based on this modulation, not this button. Thanks to this modulation, we constructed slightly different 100G transceivers using on the optical side just 1 laser, not 4 lasers like previously shown LR4 or ZR4, but 1 laser. On the electrical side, we still have 4 electrical lines, but those 1 laser transceivers are called single lambda due to the fact that we are using just 1 laser with 1 wavelength 1310 nanometers. And we have also several ranges from 2 up to 40 kilometers in this type of optical transceivers. Of course, those transceivers are not compatible with LR4 or generally transceivers based on 4 lasers, because it would be impossible to connect 4 lasers emitting different wavelengths to 1 laser on the other side. But those transceivers are perfectly suitable to use in connection with 400G transceivers equipped with 4 lasers for 100G lasers, because we are able to connect separated lasers from 400G transceivers with using those single lambda 100G transceivers.
Yeah, so coming back to the bitrate and baud rate subject, this kind of transceiver, in fact, we only increase the speed of the laser 2 times. So the lasers inside are changing the light not 100 million times, but just 50 million times. So the point is that because each light change giving us 2 bits instead of 1, we are achieving the speed of 100 gigabit. So if we want to wait for the progress in technology, probably we will not have that transceiver yet. But because we combine 2 methods, 1, 2 times faster laser change, and then amplitude modulation with 2 more states, we are able to achieve the faster bitrate quicker and be ready on the market earlier. Also, thanks to that technology, we achieved 2 other transceivers. So this is the BD transceiver using the single wavelength. So this is exactly the same approach for making the BD connection like we have with 10G. Just one laser transmits from point A to B. The other laser, the other wavelength, is used to transmit from point to B to A. So this is how we achieve the BD transceiver using, again, pump for modulation and single laser transceiver. Of course, with that approach, we are also able to gain a little bit more advanced technology. So the one is O-band multiplexing, and the other is DWDM multiplexing. They have some limitation and application behind that, which I will show on the next slides. So first of all, if we have a very short application, very short distance to do up to 3 kilometers, the best to achieve that will be to use QSFP28 transceiver, 100G DWDM single lambda, because we could install the transceiver directly into our equipment. Most of those are already equipped with QSFP28 slots. And we use just passive multiplexer. And up to distance, up to 3 kilometers, we are able to do this completely passive, because multiplexer is losing same like ODF, with just specific description of the ports, and it's very easy to connect. If we need slightly longer distances, we need to switch to O-band technology to achieve, again, very simple architecture. So passive multiplexer and still transceiver installed directly into the equipment. Of course, using the single lambda technology, we are able to gain the longer distances, even up to 120 kilometers, but this requires a bit more complex system. Because this is what Andrei says, that together with making the changes of the laser higher, we obtain some nonlinear effects in the physical part. So that's why the distance getting shorter and shorter. And one of them is, the reason of that is chromatic dispersion, which is in our fibers. So to avoid that effect, we need to compensate that. Compensating that, inserting another insertion loss to the path, that's why we need to use amplifier. And this is how the application we show on the slides appear.
We are going further to next possible speed of transmission made with optical transceivers, and we are going to 400G transceivers, still based on PAM4 modulation. And here, with the interface QSFP-DD already, we have also several options. Those 2 groups shown on this slide, we are talking about 4 or 8 laser transmission transceivers with multiplexed lasers to fit those transmission into one transmission line. So with LC connector, we are connecting the pair of the fibers. First, FR4 and LR4 for 2 and 10 kilometers are based similarly to aforementioned 100G transceivers on CWDM wavelengths, and LR8 and ER8 with 8 lasers transceivers are dedicated for 10 and 40 kilometers and based on LAN DWDM wavelengths. Of course, there is possible interoperability between types based on the same wavelength grid, but it's impossible to interconnect CWDM based transceivers with LAN DWDM. And one of the most popular usage of QSFP-DD 400G transceiver is the version of the module with MPO connector, so dedicated not for transmission in one pair of fiber, but with all 4 lasers available on the same connector, MPO12, to connect to each laser transceivers 100G single lambda I mentioned before, to make the aggregation of 100G transceivers, for example, with the modules plugged into servers, to the top of the rack switch for aggregation of these transmissions. Indeed, in that case, as we have separated lasers available on MPO connector, we are using exactly the same wavelengths, 1310. It is possible to also to use that LR4 QSFP-DD 400G transceivers on one single fiber with usage of circulators. We were able to establish 400G transceiver, 100G transmission on one single fiber with the distance up to 20 kilometers.
The beauty of 800G connection is that it's also compatible with those 100G LR1. So when we stop using LR4 and start using LR1, there will be really future-proof investment, because those devices we will be able to directly connect to 400G and 800G top-of-the-rack switches when that business come to the market. I know that now we still use the most of the connection using just 100G to 100G ports, but to be ready for the next network migration in the near future, we could save a lot of investment putting now already 100G LR1 transceiver there. So this is something which is already happening on the market. We see that, but we see also the trend that's still interconnecting between operators. They are still done based on LR4 because this is so-called standard. But for the internal use, a lot of companies already switched to LR1 to save the investment cost. So today we invest in LR1, then we will be ready for 400G and 800G generation in the future without need to replace. We are not able to do that with LR4. And of course, 400G transceiver, Andrei mentioned that we are able to use either for dual, either for single fiber application using circulators, will be compatible with the specific 800G product, which are also using CWDM wavelength. To make it easier to stack 400G on 800G switch, this 800G transceiver coming to the market with CS connector, so we don't need to use any MPO connector to connect that. We will have just separate duplex connector. We will just use CS, so like slightly smaller than LC, to achieve very easy connection, like point to point, without need to break out on the MPO connector.
We end up with PAM4 modulation, and next type of the modulation we use is coherent modulation. As we are going further with the transmission speeds and have bigger and higher frequency of the signals, we meet a lot of obstacles and technological problems with modulation and transmission of these NRZ or even PAM4 signals.
Yeah, we need to still remember that how quick we are able to change the laser. This technology is not growing that fast. Like we need the capacity, so that's why we need a bit complex modulation.
In coherent modulation, we use not only the amplitude of the signal, but also the phase and the polarization of the signal. In result, we get no more just turning on, turning off light, but something we call constellation, is the point arrangements used for coding not one or even two bits, but sets of the bits. Based on this, we built DWDM modules, and historically the first was QSFP-DD 400G ZR+ coherent transceiver, with currently with the transmitting power 0 dBm. It's this level of the output signal is very important, because with this level of the signal we are able to use it in broad field implementations, just replacing the old 10G DWDM modules. And what is very important, ZR+ compatible standard module allows to make the transmission with the different speeds, 400G, 300G, 100G, with different requirements for the OSNR in the transmission line. So 400G coherent transceivers could be compatible with two standards. OIF is dedicated mainly for DCI interconnections, and OpenZR Plus has these aforementioned different transmission modes. The last child of this coherent revolution is QSFP28 100G transceiver, which is strange. It became to the market later than 400G transceiver, coherent transceiver, due to the fact that heart of these transceivers are very powerful digital signal processor, which consume a lot of energy, and construction of the construction of the DSP with low enough power consumption for QSFP28 100G interface taken much more time than for 400G transceivers, but from this autumn this product is already available.
So the simplest application for that kind of transceiver is to build the DWDM system completely colorless using just a passive splitter. And if you want to amplify the signal, we just need to have another SFP, QSFP28. So in fact, we need 9 QSFP28 ports to build the whole line system up to 120 kilometer with the aggregated speed of 800 gig. Using the pluggable optical line system, so the set of amplifiers built in into the QSFP28 form factor. Of course, when we took into the coherent revolution, we could find a lot of space in the network when that transceiver could be installed. So first of all, the 100G ZR, so 100G transceiver, the main purpose of this transceiver is to install that in the access network. So we will connect our aggregation switch together with our OLTs. We will connect it together with a radio base station to make it ready for 5G and 6G. We could connect it as well with some enterprise customer which needs more bandwidth. The 400G ZR, so this standard by OIF, we are able to use it with the data center interconnection, and the ZR Plus, which has more modulation, the different types of speed, we could use in both in aggregation and in the core network. For today, you see the list of the hardware when we already qualified those transceiver, but of course more are coming and we are ready to test more.
Feel free to contact us and talk with us at our stand. And now, thank you for your attention.
If you have any question on technology, yes.
Okay, for the 400 gig transceiver one fiber, you talk about optical reticulator. The optical reticulator is on the transceiver or is an external device?
For today, to single application, single fiber application is the external one.
Okay, thank you.
Anybody else? So thank you.
Thank you.
Thank you again. So, because IP resources are very important for all of us, we have now a presentation from IPXO on management of IP resources and in general management of IP space. It's, yeah.
Thanks.
Sorry? Yeah, of course, of course. So that's the remote, right? Just testing it out. I broke it already. Thank you. So first of all, hello everyone. Thanks for having us here today. Congrats to the organizers on a great event. Yeah, my name is Paulius Judickas. I'm VP of Strategic Alliances at IPXO. And well, to give you, a one-sentence introduction on what we're doing, we are an ecosystem that's leveling the playing field for both IP holders and IP lessees. So for this meeting, for this event, I thought, everyone's doing presentations on what they're doing best, on their specialities, on their expertise. So this got me thinking, we are the best, and I can proudly brag about this, with IP address sustainability. So this is what I decided to do, to give you a better understanding, an overview of a global IPv4 market, where is it heading, the trends for it, and yeah, obviously give a short presentation about the company itself. So yeah, my presentation is about tackling global IPv4 shortage. And first and foremost, there's an open question of how sustainable is IPv4 addresses. We are all used to, knowing one thing, that you can buy them. You can get some of them from your upstreams, your ISPs. So I brought you some numbers, some graphs. I hope you find it interesting. So first of all, largest holders, I looked into BGP tables. So I looked into largest IP holders with the largest allocations that doesn't use their IP addresses. So the space is unadvertised. So yeah, first of all, you have Amazon. And within these 10 enterprises, there are more than 200 million unused IP addresses, only from these 10. Amazon leading the pack with almost 90 million completely unadvertised IP addresses. Then I looked into biggest advertisers, who are the guys who are advertising the most IP addresses. So within 15 organizations, there are 900 million IP addresses announced on the internet. That's more than a quarter of the whole usable IPv4 space. Then I looked into total allocated IPv4 pool. So some of you may know that in total there are 4.3 billion IPv4 addresses. Back in the 80s, people thought, hey, there will be more than enough IPv4 addresses because people will only have one computer per home or maybe per apartment block of some sorts. Apparently, we have, 3-4 devices each. So we ran out of space pretty quickly. And now we still have 650 million of unannounced IP space. So you already saw in my previous slide, where is it hiding? At least a good portion of it. Then, obviously, I've looked into transfer logs. Who are buying, who are selling the IP addresses? You can see that 3 companies, and this is another fun fact. So Amazon, Microsoft, and Google, and I've looked into last 10 years of buying and selling, transfer market in general. These guys buys out 70% of all global transfer market for IPv4 addresses. So we have 3 companies. And I did some rough maths. They have invested anywhere from $3 to $5 billion within 3 years. So for anyone telling me that IPv4 is supposed to be sunsetted and it's over, tell me again whenever you see Amazon buying IP addresses and spending billions on it. Top sellers. This is actually another fun fact. So the largest holders for IPv4 space is companies that, has nothing to do with IP addresses in general. You have your Ford Motor, you have, United States Postal Service. So yeah, top 3 buyers bought more than 110 million IP addresses in 3 years. So again, and as you saw in Amazon's case, they're not putting it to use. They're hoarding the IP space. They have a bigger picture for some time in the future. I guess we'll see what's their plan on it. Then some fun facts about transfer. So transfer types. There was a trend during COVID days that companies mostly did mergers and acquisitions to gain IP space. So it was actually cheaper to buy the company with the whole IP allocation they were allocated, rather than buying IP addresses themselves. This pattern has changed a bit. Now we can see that, they're mostly doing resource transfers now. I looked into inter versus intra-IR transfers. Well, to be expected, almost 90% of the whole transfers are happening within the same registries. Another interesting statistics. I've looked how registries are changing in terms of sizes of their IP space. So every single registry is actually bleeding IP addresses, and only RIPE is growing. And actually, Microsoft has something to do with that, because as of lately, Microsoft is transferring all of their purchases to RIPE's LIR, and it got me thinking, what are the benefits of it? And I can only guess. I don't believe that it's the main factor for them, but one of the factors could be the case where payment schedules, fee schedules are completely different. So within ARIN, within LACNIC, for example, you can pay up to $380,000 per year because you hold a lot of IP space. RIPE is way more lenient in this sort. You're only paying, $1,600 per year, and you can have as many IP addresses as you want. RIPE is the most forward-thinking registry out of all five. And yeah, they're the only ones who allows you to keep a legacy status for your IP addresses. So this could be one of a factor as well. Then I looked into transfer price changes. And for those who have bought or have sold some IP space, some time ago or maybe recently, you guys probably noticed the drop in current IPv4 pricing. Again, a couple of factors for that. Obviously, there was an economic downturn. A lot of companies started seeking for, fast money. Apparently, IPv4 addresses are a surprisingly liquid asset. So they dumped it into the market. The market got over-flooded. And the pricing, especially for the large blocks, so you can see the blue line is indicating /16s and higher and bigger subnets. Those are the ones sought after by the hyperscalers. Got way cheaper because hyperscalers decided to stop using IP brokers, and they went into the market themselves. So they directly started talking to the companies, and so they managed to bring the whole market pricing down almost in half. Then I decided to do an interesting research. I simply put S&P 500 index prices, index graph together with IPv4 pricing, and there's a match. I think this, this correlation is fairly understandable. Whenever economic grows, there's more and more need for infrastructure. The businesses are growing, thus the demand for IP addresses, including all of the internet resources in general, is growing. So we saw an increase in price. Now we're looking into a bit of a downturn. Same thing is happening with IPv4 prices. So what are the alternatives of getting IP addresses instead of buying? Most of you probably heard about the waiting list. So within ARIN, you would have to wait 2 years to get a /24. You would have to wait at least 18 months in RIPE to get your /24. And now I have a short trivia, actually, and a prize. So I need a number, just a guess. How long it would take for you. So if you are already applied and you're first in the list in LACNIC, guess how long it will take for you to get your /24? Nah. No. I can give you a hint. So ARIN, 2 years, 18 months for RIPE. LACNIC is way longer. Bit less than 10. Less, more. Who said 7? Come here. So yeah, it would take you at least 7 years to get your /24 from LACNIC. Thank you. No worries. And currently, the last, entrants in the waiting list would have to wait 10 years to get their first /24 assigned to them. So probably waiting list is not that good of an option. Then we have more alternatives. And I thought, cloud is a pretty good example for this. Back in the day, up until, I'd say, 2008, 2006, everyone was used to having their servers on site. We all had, our engineers, network engineers, local teams, checking that that computer must always run because that's our billing, that's our legal systems in place. Then, Amazon came into place. A couple of years later, Google introduced their cloud. Microsoft introduced Azure. Thus, there was a new trend of moving everything to cloud. Cloud became a huge, buzzword, and everyone was migrating to cloud. Well, now we see a reverse trend, I'd say. On-site being brought back to the popularity, basically. So alternatives to IP acquisition is IP leasing. Previously, IP leasing was done in this sort of wonky way. You would have to send out multiple emails. You would have to wait a couple of weeks to get a reply from the brokers and whatnot. So, and there were risks involved into it, abuse observability, KYC. You never could know, who's using your IP addresses. Anyone could hijack your unused IP space by simply starting to announce it by sending some fake PDF LOAs. Obviously, there were some benefits to it as well. And again, I looked into some statistics. I went back to the pricing. Guess what? Buying, acquisition, and leasing pricing has exactly the same pattern. It peaked at COVID. Now it's going a bit down for both. So we thought that, there's a niche for a solution, but we would need to, unify the internet governance. We would need to unify businesses, internet service providers, to create this sort of an ecosystem, again, a level playing field for everyone, for those who has too many resources. And let's be honest to ourselves. Based on the books, on registry policies, you are supposed to return the space if you're not using it. I've asked 4 out of 5 registries. No one ever did that. Everyone understands, the value the asset is bringing, but they rather, just blindly announce the space, not to give it away, but to keep it for themselves because we might need it in 20 years or something. So everyone's doing that. But at the same time, there are loads of companies who are struggling to get any resources in place. So if you're starting business today, whether it's a hosting, telco, ISP, you name it, you would either have to dish out quite good money to get some IP addresses, or you would have to look into these sort of alternatives. This is how IPXO was born. We patented our RPKI backend. We patented our IP reputation management and observability system. And we decided to introduce a solution that would help all of the companies to temporarily redeploy some of their unused IP addresses into the market, allowing others to establish, grow. And currently we have, this is a slide from a month ago. Currently, we have almost 4.5 million IP addresses. Our utilization rate rarely goes under 80%. Almost 500 IP holders, more than 1,000 leasees. We don't allow anyone to come onto the platform and get IP addresses, obviously. We're doing KYC processes, know your customer, know your business processes. And we have some major logos, and these are the only ones who, allowed us to display our logos. Apparently, we have to sign a lot of NDAs whenever we're talking with large enterprises. And so if you're thinking on what to do with your unused IP space, you basically have 2 options in place. Either you sell it or you can choose to monetize it, lease it. So if you're selling, yes, you're looking into a significant amount of money, but you're losing the ownership. You won't benefit from the global increase in prices for IP addresses. And it's not a recurring revenue. So for a lot of companies, it's way better to have a steady, signed revenue in place rather than just a single injection of money. If you're, monetizing, leasing the space, you get to retain the ownership. You're always benefiting from the increase in pricing. And again, as I've mentioned, that's a stable revenue that you can be guaranteed that you will be getting for 5, 10 years in the future. The model itself is super simple. So we get IP addresses from the IP holders that doesn't use the IP addresses, and customers who are leasing the space is issuing payments to us. We're issuing monthly payouts to IP holders while we take care of the IPv4 provisioning for the end customers. And yeah, the benefits that we offer for IP holders is, as I've mentioned, KYC processes. Every single registrant has to undergo, well, pretty strict and pretty deep business verification. Everything's on the platform is automated. So, you know, you start from issuing ROAs all the way to IP reputation management. Then we introduced automated geolocation management, hijack protection. We even started to offer inventory management for those who are bringing, you know, hundreds of thousands of IP addresses in one go, not to overflood the market, not to drop the prices too low. So yeah, as I mentioned, currently we're heading to 4.5 million IP addresses. We're looking to end the year with more than 6 million on the platform. While you see the growth in, you know, global volume of our marketplace, our utilization never goes down. And this only shows that there is a huge demand for IP addresses and huge demand for IP address leasing in general. We can only guess, you know, how many deals are happening the old school way, through brokers, through directly between the companies. Most of the IP addresses we have on the platform comes from RIPE, obviously. RIPE and ARIN are the only two registries that, well, officially, publicly, and based on their policies, allows IP monetization in general. For other registries, we can only monetize the legacy IP space because technically, registrars doesn't have a word, doesn't have a say for those IP addresses. So yeah, that's why we're looking into only single digits from those three registries. Average price per IP, yeah, it was peaking during COVID, like I've shown you, based on, you know, global acquisition prices, global leasing prices. Currently, we're looking into 40 cents per IP. Our top industries, those are mostly, you know, either infrastructure or service providers. Top countries for the leases. We're Lithuanians, by the way, so we're proud that at least we're serving our country fairly well. It somehow managed to get into the second place, and it's still growing. Top AS numbers that our IP addresses are being announced on. So again, pretty well-known and pretty established names. Even M24/7, by the way, is #1 AS in our platform. So quite a lot of IP addresses coming from IPXO is announced there. So looking from leasee perspective, they kind of got used to using our platform, and, you know, companies that tested it and then settled on our platform understood that there is a huge flexibility with using IPXO, because first you can choose from a huge pool of IP addresses, like all registries, whatever CIDR you need. You can swap IP addresses if needed. ROI is way better compared to buying IP addresses, because again, you don't have to, you know, put a lot of money up front. You can skip the CAPEX working model. You can stick to OPEX. You can scale as you go. Fast access to IP addresses, and I mean fast. You can get your IP addresses. Well, you can get ROAs issued to the IP addresses you freshly leased within, well, 90 seconds, 2 minutes at most if it lags somewhere in the system. So there's no comparison to any other way of getting IP addresses. Ecosystem flow. Again, as I've mentioned, this is in a bit more detail than I showed you before, but, you know, IP holders are putting IP address. Do I have a pointer here maybe? I think I do. So yeah, IP holders are putting IP addresses onto the ecosystem itself. IP leasees who passed our business verifications comes onto the platform. We are doing the provisioning, we're doing the management side of business, we're doing the abuse observability, and we're issuing payments back to IP holders. So it's a closed circle, it's an ecosystem, as I've mentioned. Yeah, and a short outlook for the future. So, you know, people tend to say that, well, demand for IPv4 is only going lower and lower, and there will be need for IPv4 addresses. But this is actually only from our comfortable position in US, in Europe, because, well, we have capital, we have knowledge on how to deal with it. Whenever we're talking with LATAM companies, whenever we're talking with Asian companies, most of the biggest telcos in those regions are still running on IPv4 addresses, and they will be doing that for the foreseeable future for a couple of reasons, actually. First of all, hardware. They either don't have a capital to do that, or they don't see a need to do that. And it's really hard to convince your, publicly listed company CEO, especially whenever he's seeing his stock price is going up, that you need like 10 million to upgrade your infrastructure. Would that help our stock price? Probably not. So guys, just stick to whatever you have and deal it whenever you stumble upon the problem. So we will be still looking into this continuous shortage of IPv4 addresses. Supply is limited. As you've seen, there are companies hoarding IP addresses, and I mean hoarding. Spending every dollar Amazon's case, probably not every dollar they have. That's probably pocket change for them, but in general, they're trying to get their hands on as many IPv4 addresses as they can. They have plans for the future. I'm sure the justification is because of AWS cloud, but why that space isn't even announced, they're just keeping it in their drawers, basically. But at this point, depletion of allocations, another big factor. There won't be any new IPv4 addresses. The demand is only increasing. And I've mentioned LATAM, I've mentioned Asia. It's technically not true. The demand is increasing all across the globe. There are new companies establishing, more and more businesses are digitalizing. So there is bigger and bigger need for IPv4 addresses. Slow transition to IPv6. Again, apart from financial incentives to move to IPv6, there is generally a shortcoming in knowledge on how to use, how to manage, and how to migrate to IPv6 addresses. There's a problem with all the hardware. There's a problem of old network engineers who are not keen on learning anything new, and economic factors. You have big players hoarding the space, big players who has deep pockets, and you're basically competing with them to get your hands on some IPv4 space. So yeah, tough luck for those who didn't get their allocations back in 90s. And yeah, I have my own Q&A slide, by the way. So any questions from the crowd?
Very interesting. So you noticed what happened and you did it.
Sorry?
You noticed what happened with the IP space and you did it.
Told you.
So any questions? So, okay, maybe on the
I guess I covered everything.
Yeah, yeah.
Thanks, everyone.
Okay. So now I will invite Telegroup for presenting some things about cleaning fiber optic connectors in order to assure good fiber link and little attenuation, I think. So it's very important because you see, fiber is still the biggest issue, the biggest asset we have, except the IP space.
Bună ziua, numele meu este Cătălin Dănilă, sunt Technical Support Manager la Telegroup. Astăzi voi vorbi despre importanța curățării conectorilor multifibră. În principiu este o prezentare cumva care vine în urma celei de la Salumanus, în sensul că vom vorbi despre partea asta de conector multifibră în contextul rețelelor de mare viteză, de 100 de gigabit sau mai departe. Da? Și cred eu că este momentul potrivit în prezent, pentru că din ce în ce mai mulți dintre operatori și o parte din clienții noștri vin la noi cu următoarea poveste. Tocmai ce am upgradat rețeaua, am avut cazuri inclusiv de la 40 de gigabit să se plângă de problema asta, am upgradat rețeaua, am pus echipamentele, intru pe echipamente și telemetria pe care mi-o trimite este ok, în sensul că nivelul la recepție este suficient de mare, astfel încât să nu fie probleme pe partea asta. Deci sunt în parametri și totuși linkul are probleme. Am rată mare de erori sau mai știu eu ce. Și motivul de cele mai multe ori este curățarea conectorilor, contaminarea conectorilor și lipsa curățării conectorilor. Și despre asta o să vorbim astăzi. Începem cu definiția unui conector optic.
îmi permite la bază un lucru foarte simplu, realizarea unei conexiuni semipermanente între cele două segmente de fibră. Le pot clasifica în mai multe direcții. Cel mai simplu ar fi după modelul conectorului. Avem conectorii clasici deja, vechi, FC, SC, LC, în continuare aflat în utilizare. Și mai în partea din dreapta avem și conectorii mai noi, în special MPO. Pe urmă îi putem clasifica și după polizare, PC, UPC sau APC. După instalare sunt conectori cu ce se instalează pe cablu sau conectori de panou. Și vreau să ajung aici, la ultimul criteriu, cel al numărului de fibre. Și am pus eu acolo ST, MTRJ și MPO. Diferența mare, deși e doar de la 1 la 2 fibre, e undeva aici. Deci marea schimbare de paradigmă este între conectorii simplex, să-i spunem convenționali, și MTRJ-ul, care cumva este tatăl MPO-ului pe care îl folosim astăzi destul de des în rețele de mare viteză. Și acum, dacă ar fi să facem o comparație între cele două mari familii de conectori, așa avem un conector SC foarte popular. Vedem că el are o secțiune circulară, ferula este circulară și, bineînțeles, cum spune și numele, îmi permite conectarea unui singure fibre. Ăștia, în general, sunt folosiți în aplicații tradiționale, omniprezenți, să spunem, da? Și au marele avantaj că, cel puțin spre deosebire cu cei multifibră, când îi comparăm cu cei multifibră, sunt mult mai ușor de instalat și întreținut, pentru că pentru fiecare fibră avem un singur conector. De cealaltă parte, MPO sau generațiile mai noi, pentru că sunt și generații mai noi. Acesta este un MPO mai vechi, cu 12 fibre pe ferulă, dar există și MPO cu 16 și există și generațiile mai noi, precum MMC-ul, și mai miniaturizat decât MPO. Vedem că ferula are o secțiune rectangulară și în cazul conectorului figurat aici, el poate să aibă în final în jur de 6 rânduri de câte 12 fibre pentru un total de 72. Există variante și cu un număr mai mare de fibre. Acum, deoarece îmi permit densități mai mari, MPO și toată familia asta de conectori multifibră, în general, sunt folosiți în centre de date. Da? Sunt ideal pentru legături de la 40 de giga în sus, pentru că am văzut, cum ne-au arătat și colegii de la Salumanus, echipamentele active încep să obosească, încep să gâfâie. Da? Și din cauza asta, o variantă de a crește rata de transfer, pe lângă folosirea modulațiilor mai sofisticate, precum PAM sau cele coerente, e pur și simplu să adăugăm mai multe fibre și să avem mai multe leni, mai multe benzi de câte 10 giga. Și așa obținem, spre exemplu, 40 de giga de aici. Luăm conectorul ăsta, 4 din fibrele din stânga vor fi folosite pentru 4 lane-uri de câte 10 gigabiți, iar celelalte din dreapta, de aici de undeva, ultimele 4, vor fi pentru sensul opus, tot la fel 4 lane-uri de câte 10 gigabiți. Și o metodă foarte economică de a obține link-uri de mare viteză, doar că, mare grijă, când începem să instalăm conectorii de tipul ăsta, avem nevoie de microscope și produse de curățare speciale. Și aici e problema. Dar înainte de toate, hai să vedem cam cum lucrează un conector clasic, convențional. În cazul ăsta am prezentat un conector LC, pentru că în continuare este foarte folosit, chiar și pe link-uri pe 10, 40, 100 de gigabit și mai încolo. Da? Și avem conectorul ăsta LC-UPC, avem corpul conectorului cu albastru, manșunul de cauciuc chiar și îmi permite mie aici să nu se streseze fibra prea tare când este din conector, ferula care face partea de aliniere. În cazul conectorului LC și majoritatea conectorilor convențional, ferula este din ceramică. Vom avem un ard de pretensionare care o să vedem că menține contactul între cele două ferule atunci când conectăm cei doi conectori. Rășina epoxidică și, în ultimul rând, fibra care ajunge până în capătul conectorului. Ăsta e foarte important, da? Și când luăm doi astfel de conectori, îi conectăm prin intermediul unui adaptor sau I, mai cunoscut la noi în țară. Adaptorul respectiv este format dintr-un corp, în cazul LC-ului de plastic. La conectorii mai vechi, acest corp al adaptorului era din metal, FC, ST-uri. Și în interior am un manșon de aliniere ceramic, care mi aliniază, o să vedem, cele două ferule și implicit cele două fibre. Introduc și celălalt conector. cele două arcuri de pretensionare se comprimă și am contact fizic între fibre. Cam asta este, să zicem, secțiunea unei conexiuni convenționale. Acum, dacă facem comparația cu un conector multifib, o să vedem că în parte lucrurile sunt similare. Avem același corp al conectorului, manșonul de cauciuc, îndeplinesc amândouă același rol. Pe urmă, marea schimbare este undeva aici, în dreptul ferulei, pentru că, vedeți, deja ferula mea nu mai este ceramică, ci este din material plastic, e un material plastic compozit și prinsă în ferulă vedem că avem doi pini de centrare. Da? De data asta o să vedem, în cazul conectorului multifibră, centrarea nu se mai face prin intermediul manșonului de aliniere din cadrul adaptorului, ci prin intermediul acestor pini de centrare și a două găuri omologe pe conectorul celălalt, pe conectorul mamă. Da? La fel, același arc de pretensionare și fibră de data asta, fibră ribbon. De cele mai multe ori e fibră ribbon aici. La fel, animația, de data asta, cum spuneam, deoarece adaptorul meu nu mai joacă un rol activ în alinierea axială a celor două ferule, nu mai include niciun fel de element de aliniere. E pur și simplu o carcasă de plastic cu niște clipsuri care să-mi țină cei doi conectori în contact. Și dacă totul e bine și conectorul e de calitate și noi am avut grijă de el, pun cele 12 sau mai multe fibre în contact și am o legătură foarte bună. Pentru că motivul pentru care noi folosim astfel de conectori, cum să zic, sunt mai multe de fapt, avem densități foarte mari, avem lățime de bandă foarte mare și în final, dacă îmi joc cărțile cum trebuie, am și costuri foarte mici per bit. Dar asta e valabil doar dacă conexiunea pe care o avem este o conexiune de bună calitate. Și din păcate, aici, cum spuneam în prezentarea mea, vine cumva în urma celei de la Salumanus, echipamentele de mare viteză sunt mult mai specifice, mult mai stricte când vine vorba de performanțele acestor conectori. Da? Și pentru asta trebuie să vedem cam ce presupune o conexiune bună. Și în ordinea importanței am spus eu că avem nevoie de doi parametri să fie ok. Pierderile și reflectanța. Acum, multă vreme, accentul se punea pe pierderi. Da? Foarte important era ca în final pierderile pe conectica de pe segmentul respectiv de fibră să fie foarte bună și asta era în mare parte suficient. La 1 giga, la 10 giga, de obicei acolo era accentul și încă este. Da? Pentru că asta mă interesa. Pierderi mai mici, un semnal atenua mai puțin și lucrurile se rezolvau. În schimb, o să vedem pe slide-ul următoare, echipamentele de 100 de giga și mai rapide au nevoie și ca reflectanța să fie foarte ok. Și dacă pierderile sunt raportul exprimat în decibeli între puterea incidentă pe conector și cea care este transmisă mai departe, reflectanța este raportul între puterea incidentă și impulsul acesta, reflexia aceasta cu portocaliu, care se întoarce înspre emițător. Da? Și, cum am zis, se schimbă lucrurile și trebuie să fim atenți în prezent, mai ales dacă avem lucruri de mare viteză, nu doar la pierderi, ci și pe reflectanță. Da? Și cum facem asta? Păi, în principiu avem nevoie de 3 condiții pentru o conexiune bună. Avem nevoie de o aliniere precisă a miezului celor două fibre, similar cu atunci când sudăm fibra, doar că atunci partea de aliniere cade în sarcina aparatului de sudură. Avem nevoie de contact bun între cele două fețe și o suprafață cât mai curată la zona de interfață. Și mereu zic eu că tehnicile moderne de proiectare și producție fac o treabă foarte bună în îndeplinirea celor două cerințe. De noi depinde cea de-a treia. Da? Noi trebuie să ținem conectorii curați, în stare bună. Pentru că o să vedem, în funcție de tipul contaminării, că e vorba de contaminare cu praf sau cea cu lichide, pot să am un impact foarte puternic asupra performanțelor conectorului. De obicei, impactul particulelor de praf este mai problematic, mai semnificativ. Chiar dacă în partea aceasta vedem că lichidele arată mai dramatic, să zicem așa. Da? Și ce se întâmplă atunci când avem o contaminare pe una dintre fețele conectorilor? În principiu, ea îmi introduce acolo un mic gol de aer și asta îmi duce pe termen scurt, o să vedem, la pierderi și reflectanțe crescute și pe termen lung, dacă insist pe partea asta și tot conectez acei conectori, voi avea uzură prematură. Și asta o vedem cel mai des în cadrul echipamentelor de măsură, care văd pe parcursul durației de viață mult mai multe conectări decât un patch cord sau un conector folosit în rețea. De obicei, iau patch cord-ul, l-am scos din pungă, e curat, pentru că producătorul trebuie să-l testeze și atunci, dacă l-am introdus foarte rapid, șansele sunt mai mici să fie contaminare. Da? Dar la aparatul de măsură acolo lucrurile sunt mai problematice, pentru că un aparat de măsură poate să vadă într-o singură zi 10 sau poate peste 100 de conectări. Și acum, când vorbim de conectorii multifibră, lucrurile se complică un pic și pentru exemplificare am ales o pereche de conectori MPO, partea unui kit de fan-out. Este un kit destul de des întâlnit atunci când vreau să conectez echipamente care folosesc 4 lane-uri, da? 4 fibre pe fiecare sens. Și cam așa arătau conectorii. Ei au fost niște conectori care au fost lăsați, cred că vreo 2-3 ani in the wild, cum ar veni, în sensul că nu am avut foarte mare grijă despre ei. Și dacă ne uităm, putem vedea urme de contaminare. Vedeți în zona asta. Destul de multă contaminare. Cel de sus, bineînțeles, este mamă, cel de jos, tată. Destul de multă contaminare, da? Și deoarece suprafața, cum am zis, în ani de zile în cât au stat ei, a fost contaminată, am văzut că o metodă de tip uscat nu era suficient de bună. Și prin urmare, pentru curățare am adoptat o metodă de tip umed uscat, în 3 etape. În principiu am folosit o curățare umedă la început cu ajutorul bețișoarelor din material sintetic și a unui solvent dedicat, FCC2 în acest caz. Am insistat în zonele mai problematice, în sensul că ne interesează mai ales la conectorii multifibră. Suprafața e mult mai mare a ferulei și acolo trebuie să punem un pic accent atât pe zona din jurul fibrelor, dar și prin zona din jurul pinilor de centrale, respectiv a găurilor, da? Din omologe, pentru că acolo tinde mizeria să se adune și iarăși cu efecte destul de nefaste. Și ultima parte, am finisat, să spunem așa, cu 2 clicuri dintr-un creion de curățare, one click cleaner dedicat. Și haideți să vedem și efectele. Cam așa arătau cele 8 fibre conectate în starea inițială, atunci când conectorul era contaminat. Da? Și vedem că avem o variație destul de mare a performanțelor, în sensul că am câteva în zona asta unde sunt super ok, până în 0,3 decibeli. În schimb, am și prima fibră de altfel, care are peste 0,75, cam cât zice standardul vechi. Deși acum sunt, în funcție de standard, ținta e mai degrabă un 0,5 și vedem că și aici fibrele 10 și 11 depășesc această valoare. Da? Și am curățat prima dată, folosim metoda de pe slide-ul trecut, și vedem că s-a redus aici dramatic, da? De la 0,8 la 0,2 decibeli. O reducere semnificativă a atenuării. În schimb, observăm pentru fibrele 9 și 10 pierderile s-au înrăutățit. Da? Și asta e cumva ceva ce am găsit destul de des în practică, în sensul că în lipsa unui microscop, contaminarea migrează și atunci ce se întâmplă? Te trezești că cureți și crezi că faci o treabă foarte bună, dar aduce altă mizerie din altă parte. Și iarăși vorbim de contaminare la nivel de microscopic. În mod clar nu o vedem cu ochiul liber, chiar și cu zoom de 50 de X nu e vizibilă. Da? Și asta s-a întâmplat aici. Am mai curățat încă o dată și în final să zicem că am redus pierderile la niște valori acceptabile, mai puțin în zona asta. Da? Dar chiar și așa observați că mizeria migrează și asta înseamnă că trebuie insista mai mult. De obicei și pentru noi a fost un șoc, mai ales dacă am conectori care au fost foarte, cum să zic, nu s-a avut grijă de ei, în sensul că nu se pun capacele, sunt lăsați în pungi, rupte, în geantă, undeva unde se expuși factorilor de mediu, ajung la o contaminare destul de păcătoasă, astfel încât chiar și în urma a 2-3 curățări să nu poți să-i aduci undeva unde ar trebui să fie. Dar mai important decât atât, pentru că multă vreme, cum am zis, accentul era pus pe atenuarea conectorului și nu pe reflectanță, vedem acum un grafic și cu reflectanța. Da? Și în starea inițială vedem că majoritatea era ok, de data asta problema mai mare era în zona fibrelor 10 și 11. În urma curățării s-a redus reflectanța, dar în continuare observați că pe măsură ce insist, în continuare rămâne problema de aici. Și acum, o reflectanță de minus 55 nu e foarte rea dacă vorbim de o comunicație, să zicem, la 10 giga sau mai jos. Da? Cerințele nu sunt atât de stricte la genul ăla de lățime de bandă, în sensul că majoritatea standardelor de 10 giga tolerează chiar cazul cel mai prost, undeva la minus 13 decibel. Deci sunt mult sub pragul ăla. Dar lucrurile se schimbă și e posibil atunci când fac un deployment pe un link de mare viteză să văd de fapt că conectorii nu sunt suficienți de curați. Da? Și din ce cauză contează reflectanța conectorului? Păi e simplu. Dacă am o transmisiune analogică și poate acolo o parte din noastră ați fost mai familiarizați cu problema asta a reflectanței conectorilor, de foloseam conectori APC, verzi. În comunicația analogică îmi crește zgomotul transmițătorului și se reduce raportul semnal-zgomot. Da? Și aveam probleme cu TV-ul. La fel pot să am și probleme la nivel de puteri mai mari, în cazul link-ului interurbane și iarăși era un scenariu în care se foloseau conectori APC, E2000 APC, spre exemplu. Da? La comunicațiile cu mare viteză poate să crească și interferența la nivelul semnalului emis de sursă și se modifice aici destul de rău, mai ales în aplicații de VDM, lungimea de undă și nivelul de putere admis. Da? Deci pot să am interferențe intercanal, pot să am variații de nivel de putere, iarăși lucruri de evitat și cu atât mai mult dacă echipamentul în sine emite la puteri peste 10 mW sau 10 dBm și nu este protejat, pot chiar să risc deteriorarea emițătorului. Da? Și am făcut eu o animație. În principiu, reflectanța e o problemă ce apare la emițător ca idee. Deci nu receptorul este afectat. Multă vreme nivelul scăzut al puterii era o problemă la recepție. Da? Reflectanța este, sau optical return loss, atenuarea prin reflexia întregului tronson, este o problemă ce ține de emițător. Și din păcate emițătoarele astea pe linkurile de mare viteză sunt mult mai susceptibile la genul ăsta de reflectanțe mărite. Da? Și haideți să vedem câteva standarde. Am 100 de giga CVDM4 care folosește 4 lungimi de undă și vedem că deja avem minus 26 de decibeli reflectanța pentru un singur conector. Pentru alte standarde e definită ca în funcție de numărul de conectori cascadați pe tronson. Deci cu cât am mai mulți, cu atât vedeți că reflectanța deja trebuie să fie din ce în ce mai bună. Dacă CVDM4 la 100 de giga tolerează și un pic de uzură sau contaminare, observam că deja dacă am 6 conectori, 6 perechi de conectori, mai bine zis, la 200 giga FR4 sau FR8, vedem că deja conectorul trebuie să fie curat. Da? Și lucrurile nu se fac decât să se înrăutățească în funcție de echipament. Da? Vedeți că la fel și aici avem tot așa minus 38. Din punctul ăsta de vedere, cel mai rău stă standardul DR4. La 200 și 400 de giga, mai ales dacă avem mai mulți conectori, 5 sau 6, deja suntem în zona conectori UPC curați. Deci ar trebui să fie un conector UPC albastru, da, cum îl știm toți, în stare ca din fabrică. Ăsta e motivul pentru care și eu, acum vreo 2 sau 3 ani, am fost surprins. Spre exemplu, toți conectorii MPO folosiți pe single mode sunt APC. Da? Deci ar trebui să fie verzi, deși nu mai e marcat. Sunt galbeni sau mai fac US Connect, știu că fac verzi, o variantă verzi, dar e un branding de-al lor. Deci toți conectorii sunt APC, pentru că în prezent, la linkuri de genul ăsta, și reflectanța contează. Și asta e mesajul pe care vreau să transmit. Da? Și acum, dacă ar fi să tragem câteva concluzii. Acum, comparativ cu cei simplex, conectorii multifibră sunt mult mai susceptibili la contaminare din cauza zonei de contact mărită. Tot zona de contact mărită și geometria, cum am zis, din jurul pinilor, îmi greunează mie îndepărtarea totală a contaminării. Și asta e iarăși o problemă, pentru că există riscul ca particulele să migreze semnificativ. Mai mult decât atât, contaminarea ușoară medie afectează în general reflectanța și mai puțin atenuarea introdusă. Deci mare grijă, pentru că e mult mai importantă inspecția comparativ cu linkurile cu care poate majoritatea suntem obișnuiți, da? Pentru că la 100 de giga sau peste am văzut echipamentele sunt mai susceptibile când vine vorba de reflectanța crescută. Și în ultimul rând, așa ca o, cum să zic, ceva de ținut minte, dacă ar fi pe din toată prezentarea mea, contaminarea conectorului poate să fie cauza unei probleme atunci când, încă o dată, măsurați nivelul de putere sau vă uitați la nivelul raportat de putere din SFP și vedeți că totuși e în intervalul admis, da? Și am avut nu un client, ci mai mulți care au venit fix cu povestea asta. Am făcut update, mă uit pe switch, nivelul de putere este în parametri și totul mintă backup-ul pentru că am berul mare, da? Sau mai agață sau chestii de genul ăsta. Și cineva chiar a stat o lună jumate în data center și a luat o conector la curățat, tocmai ca să-i aducă unde ar trebui să fie. Pentru că lucrurile se schimbă. Și se schimbă și nu doar pe partea de conectori, ci și pe partea de sudură în general, mai ales pe manufacturing. Da, cam asta ar fi. Vreau să vă mulțumesc pentru atenție. Vreau să mulțumesc și Interlanului pentru evenimentul super ok.
Mulțumim pentru prezentare.
Da, și dacă aveți întrebări.
Any questions? Întrebări?
Da, se întâmplă. Și acum lucrurile sunt mai în detaliu, dar în principiu...
Mă scuzi, la conectorii multifibră n-am lucrat cu ei, dar mă gândesc fizic dacă mi-apare o substanță, un lichid, ceva, lungimea de undă apar și reflectate și lungimea de undă se duce pe celelalte fibre.
Da, acum poate să fie, deși la cum e geometria acolo, e un compromis ce drept, pentru că ele sunt foarte apropiate, una în vecinătatea celelalte, dar încă nu asta. Lichidul aparent ajută pentru că reduce indicele de refracție, aduce indicele de refracție mai aproape de cel al sticlei. Deci asta e ironia, da? Dacă am niște conectori în apă, e mai bine decât să fie în aer, pentru că acolo e discontinuitatea maximă. Dar da, sunt probleme. În general, problemele sunt asociate cu zonele acelea de lângă, din jurul pinilor, unde nu poți să curăți foarte bine. Fujikura, producătorul nostru, lucrează, spre exemplu, la un produs care să curețe pinii respectivi, pentru că e zona fix din jurul lor, dar și atunci ce se întâmplă? Fiind zona mult mai mare de contact, pot să am contaminare undeva în colț și să afecteze bunul contact între fibre undeva în altă parte și e mult mai greu de, cum să zic, de depanat problemele astea, da? Chiar și cu microscop, chiar și cu surse de lumină, bineînțeles că îmi trebuie o sursă de lumină cu 12.
Da, știți că la conectarea manuală, problema asta, ca să nu apară și reflectată și interfonie între canale, se face cu gel. N-ar merge niște conectori care să aibă o...
Da, sunt de acord. Și mai bine ar fi să-i sudăm. Problema e că dacă introduc gelul acolo, există riscul de contaminare. Da, asta e. Se duce caracterul semipermanent al conexiunii, da? Pentru că altfel m-aș duce mai aproape de ceea ce se numește o sudură mecanică, o joncțiune mecanică cu gel. Și da, aș avea toleranță mai bună la niște lucruri, dar gelul acela se va comporta în final ca un magnet pentru mizerie și s-ar duce partea asta de repetabilitate. Până bineînțeles că dacă ar trebui să curăț, ar trebui în primul rând să mă lupt cu gelul, să curăț gelul și pe urmă să reaplic și să conectez înapoi. E posibil pe viitor să vedem și genul ăsta de probleme. Dar momentan lucrurile se rezolvă curățând conectori.
Și închiriați echipamente optice pentru curățat?
Da, tot ce avem demo închiriem. Și mai mult decât atât, două lucruri mai vreau să mai anunț în caz că mai sunt întrebări. Unu, avem o tombolă acolo și puteți câștiga 3, dacă vă puneți cartea de vizită în cutiuța cu tombolă, puteți câștiga 3 creioane de curățare pentru SC, LC și MPO. Deci ar acoperi cam tot gamutul așa. Și 2, în caz că sunteți interesați de toată gama de creioane de curățare și partea de inspecție de la noi, colegele mele, puteți ridica și mâna și colegele mele vă vor da un scurt pliant așa cu produsele respective.
Mulțumim!
Mulțumim și eu încă o dată!
Now we have smart optics enterprise data center interconnection. You have the floor.
No, that's this one. This one is fine. Great. Thank you, guys. You are still with me, despite the fact that you should be there and drinking coffee. My name is Piotr, and I'm representing Smart Optics company. And I think within next maximum 10 minutes, I will take you into our way, how we think that enterprise data center interconnect can look like. So yeah, let's dive in. Just few words about Smart Optics. Smart Optics is a Scandinavian company. We have 3 main offices in Oslo, in Stockholm, and in US. We are covering the whole world, more or less. We are a publicly listed company on Norway Stock Exchange, and our main and the only, I would say, offerings are layer 1 transport. So again, we heard a lot of interesting presentation here from layer 2, layer 3, and above, but I will take you a bit down to layer 1, where is the physical layer and the DWDM transport happens. So that's Smart Optics in a nutshell. This is our portfolio. I'm not going to talk about all the things. We will focus today on our open line systems and only on DCPM systems that are dedicated for data center interconnect applications. Except that, of course, we have more, let's say, sophisticated platforms that can create more topologies, not only point-to-point, but also rings, some 2-degree ROADM rings, and yeah, for large-scale service providers mainly, the DCPR, that is the ROADM networks. All right, so let's dive into the core of the topics. And what I mean by data center interconnect is the application that the customer, it's a 99% cases. So customer has 2 data centers that are connected with the 2 pairs of fiber optics, and they are not more, I mean, the length is not longer than 80 kilometers. And yeah, there are some general requirements that the customer has to throw the data from data center 1 to data center 2. So the general requirements are, the first of all, and I hear it very often, it should be easy to use. I mean, the enterprise market does not have a deep knowledge on DWDM transport. There's no dedicated personnel to configure and operate the DWDM system. So it should be as easy as possible. It should be capable of transporting Ethernet and SAN fiber channel traffic. It should be high bandwidth, low latency, especially for SAN traffic, low latency. And it should be space and power friendly. So that was the general requirements. And from a typical traffic requirements that we see is mainly for small enterprises. It's a fiber channel, mainly now 32 gig due to the Gen 7 rollout. 1 to 4 fiber channels together with some Ethernet traffic, larger scale enterprises, more fiber channel, more Ethernet, and in data centers, I mean, rather the internet exchanges, they focus only on Ethernet, and you can find there anything from 10 gig up to 100 gig and 400 gig per channel. So yeah, if we will, let's say, zoom in the 1 hour data center building and just to look what's inside, then this is our proposal. So DCPM platform, this is a small 1 rack unit platform that is connected directly over the dark fiber pair to its peer, that is DC2. And this data center DCPM module accept the DWDM transceivers. And our philosophy, our, let's say, proposal to our customers is so-called IP over DWDM, or in other words, embedded DWDM, where we, or the customer, insert the colored DWDM transceivers directly to their, let's say, SAN fabrics or the Ethernet switches. There are some cases that something in between is needed, so we call it transponder or maxponder. And transponders and maxponders are needed if you would like to have a clear demarcation point between your customer and the network points. If you would like to do encryption, that's also a good choice for transponders and maxponders. And if you would like to utilize the DWDM bandwidth in a more efficient way, so you don't want to throw several 10 gigs and consume I don't know, several channels, DWDM channels, it's better, I think, to aggregate them into one 100 gig stream and send it as a one channel. So that's the philosophy, how we think the data center interconnects could be built. If it comes to the management, there are several options. So first and obvious is SSH, the local craft terminal monitoring. It's also available the SNMP tools that you can connect to any SNMP, let's say, third-party SNMP system that can read the traps, or you can use our SoSmart Manager to manage your networks. I've just started, and I see 5 minutes. Okay, so coming to the portfolio, inside the portfolio we have two families, DCP-M 40 and 40C coherent. They all serve 40 channels, so you can throw to those systems up to 40 channels maximum. The difference is that this one is a multi-service, so you can have anything from 1 gig to 400 gig per channel. This one is coherent. What is the most important is this one. This is the very user-friendly system that is fully automated. So you don't have to, you don't need any knowledge on DWDM. It's as simple as connecting two boxes to the fiber, to the power, and system does everything by himself. So it reads the fiber, measures the fiber, it sets all the parameters inside the box, and it's ready to be used. So the summary is about the DCP-M systems. So I said at the beginning there were some general requirements and typical traffic requirements and how we fulfill those requirements. So it should be easy to use. Right, it is, because it's fully automated. It should be high bandwidth and low latency. It is. You have 40 channels. Each channel can be maximum 400 gig. So then you have a 16 terabit of traffic, right? And low latency, absolutely it is, because it's a end-to-end optical transport. So there is nothing in between. There is no optical to electrical to optical conversion. Space and power savings, absolutely. 1 rack unit and 45 watts in the normal conditions. And when it comes to the traffic requirements, right, you can have anything from 1 gig to 400 gig in an automated way. So sorry for that, I was very quickly, but yeah, the time was running. And I'm sitting over there in the corner for more information if you would like to ask me some questions, or you can drop me an email, or you can catch me during today's event in the evening.
Thank you. Sure, you'll use this coffee break.
I had no choice.
Yes. Any questions here now? No, outside. Okay. Thank you. So coffee break. Even started.
make this incorrect emotion.
Ok, so am ajuns și la ultima secțiune din această zi. Aș vrea totuși să încercăm să ne organizăm, să terminăm cât mai repede, nu de alta, dar să nu ne lungim foarte tare, că ne așteaptă o petrecere și cred că toți ne dorim să ajungem acolo mai repede. Așadar, the first speaker will be Elena Lutsenko from Reten. She will talk about the partnership as a key solutions for global challenges in telco. Okay, stage is yours, Elena. Thanks.
Hello, everyone. As looks like that rim calls, I can be loud and loud for the gate, and this is your attention for the next 15 minutes. I'm Elena Lutsenko. Thank you for having me today here. I'm very appreciated to be here and would like to share something Reten experience as a network service provider, what we face as challenges in our duties, in our telco duties. I'm coming from Kyiv. Now I'm business development for the whole group and more than 14 years currently coverage the all duties in Ukraine and Black Sea region as well. I would like to believe that everyone knows who is Reten, but I need to do cover for my marketing PR team requested. So Retens is a leading global independent network service provider connected Europe and Asia. Now we provided homogeneous DVDM and MPLS services around the world, and mostly, of course, in Central East Europe and connected to Asia. So yeah, we have purely easy product menu as Ethernet, VPN, IP transit. Of course, we can provide remote peering of the most known IXs, Cloud Connect. What is common for all the services, even if you have the own network, what is the coverage more than 140,000 kilometers around the world, is that you always need to have the partnership. Because all telecommunication about the partnership, network is the connection between different people, different networks, different parts of the world. And due to my Ukrainian experience, I can say you that we taken as connectivity as a basic needs, and sometimes we forget how it's important. And today I will try to share some insights as a practical solution with a technical approach, what we faced, how we solved, and what is important. And I can say that there's a lot of good cooperation and partnerships help us not only keeping the revenue, also keeping this world better connected. So about the Reten S9002, its key numbers. We are currently ranked as 11th on the KDS rank, and I can mention here only the one thing, that Reten not operated on USA market. It means that a purely European connectivity, and yes, we're now present in the Balkans region. This was done in 2022-2023. Why I decided to highlight it today, because it's not only says that we, for example, last year was awarded as Best Pan-European Carrier by the Global Awards in London. It's also about our planning and evaluation when we do investment. Is there some kind, not sexy business anymore, as backbone operators, yeah? What this project was done by my leading, and I can say that we started to evaluate it, cook it a lot of time, maybe 6-7 years ago, because some of you knows about our request in the past, and we try to cooperate and find the best way how to make something different on the market, how to make some resilience of will be independent. What we find in the way, it's two absolutely independent routes without any points of failure. And what is important, both of these routes terminated in Budapest and Sofia in absolutely different data center, what is connected by the own metro network. And here in Romania, we are present in the next data now. Everyone knows this good data center, and in Bucharest, and of course, in Timișoara, we are one of the first international operators who are coming to the new data centers by Orange. What is important? Yeah, I heard this some point about DDoS protection in Romanian from the guys who was in first morning section, and I can say how it's possible to work with kind of operators as a written. So we do some basic stuff as a free for any of our customers. It's our duties. It's 72 terabits traffic already, but we do it the prioritization traffic for any location. Doesn't matter if it's our own terabits presence or we use it at the backbone as a leasing capacity. It's always black hole community. The prioritization is basic for any of our customers for the connectivity. Some services who would like to do it by themselves is the extended black hole community and flow spec, of course. And what is interesting, everyone speaks now about, not about the C, unfortunately, but about the AI. And that's why I can say that Redden started to practice the solution, what is using AI as algorithm. I will not sell any application now. But yes, and the next subscriber, what is very close to the Bucharest, to Romania, it's in Budapest. That's why it's possible to try the services. I will, in the end, say who's on duty with it. So I have the question to you guys. How many people heard about the fiber cuts in Red Sea? Can you raise the hands? Not a lot of people reading paper. Yeah, what has happened, honestly to say, I really hate February due to my personal experience. But yeah, what happens in the 22nd of February, it's some, again, geopolitical issue, what is not possible to manage, but 4 main cables was fully destroyed, subsea cables. And only the one thing what was fully operated is SMW5 between the Singapore and Europe. What is, of course, in that moment, each popular newspapers wrote, even my friends who doesn't work for the telecommunication called me and asked how it can be affected their life. What will happen with this TikTok, with another known good, application. For example, a lot of Ukrainians still make the orders on Alibaba and ask it how it's possible it will be affected logistic or some else. Of course, says it's not connected directly to the logistic skills. But anyway, if you be seriously, it's take a lot to increase of RTT, packet loss, but I'm not sure that anybody follow. But what happened on the April 24 is interruption near the Bangladesh. What was make cut the last one thing what was direct capacity route subsea cable between Europe and Singapore. I will not describe how it affected the Bangladesh, for example, and because it was very, very bad situation, maybe it's also connected to what we have currently is the geopolitical situation because telecommunication is a basic for everyone. And yeah, no more cable operated. And yes, it was very important thing that is not happened with restoring. Only happened in the April is the first force. That's why what has happened in our choice, we prioritize and double our capacity on the terrestrial cable. We operated through the Kazakhstan. It's most popular of them what you have currently. And the first two is gone for the Mongolian border. It's different. Also, we do our staff as the duties to compare this is different RTT, what is interesting. You can see that it's absolutely looking glass open. What has happened before fiber cuts in the subsea and after. It means that most stable RTT is always available when you go on and combine the yard capacities using terrestrial and subsea in the same balance. And yes, 3 it's not enough, 5 it's not enough, as much as possible. I'd like to switch and the other disaster what we faced, what is long time, what has affected my own life and what I faced before. I will not describe everything, but yes, fiber cuts population. I will just share with you some example about real partnership without documents. You see that we have the 5 cross-border connection and one of them is going to Moldova. But on the 1st of March 2022, it was a problem that we didn't have enough capacity. And I understood, I was in Ukraine, in Kiev, I understood that is what is going inside with the fibers, how many fiber cuts was the cuts near the Kiev. And I understood that in some moment, Odessa and Nikolaev can be isolated from the international connectivity if something going wrong with Kiev. And I called just as a few our partners in Moldova, and the guys without any documents through the 24 hours increased our international capacity between Chisinau and Bucharest, what was bottleneck on that moment. Just, of course, for the money in the future, some else, but it's a very good example. If you trust each other, how partnership can help you to solve the some necessary. And I know that, unfortunately, a few days, this route was only one, what is a connected Odessa with international internet connectivity as well. So as new level of partnership, I can share, I will not go on each problem, but very important, physical routes, it's never enough. Yesterday on the internet measurement days, we spoke about how to measure resilience. Yeah, we spoke about not only logical, because if its physics doesn't work, logic it's okay, but it's not enough. Yeah, everyone knows how to get diesel generator always with a full tank, and very important about spare management and prognose forecast where you need it, in which part, because Romania also big country, for example. If you have the problem in the Bucharest, it will be not as easy to solve very fast in Russia or somewhere else. That's why carefully planning and cooperate with your local partners can help always to keep your network alive, what is very important. Yeah, we know everything about the high capacity batteries, and I mentioned yesterday, regulator from yesterday in Kiev, each ISP responsible to provide the telecommunication service connection without external power for 72 hours. Will not ask how many ISP can provide this kind of services here or in another country, because you're not obligated, but we are currently prepared for the very tough winter. So result for the last year of this, all the what we've done, it's 100 availability of red and IP transit during the last year in Ukraine. This year it's not ended. It will be a hard time for us. Everyone knows about it. But we are preparing, and we done what I mentioned for the previous slide, very carefully, very smart. And it's very important not to forget about the communication. What was my example? It's not only about communication with external partner, it's communication about your team. If you show your resilience and your understanding what is going on, and share with them your plan, even for the duties business is general life or some emergency plan, it always needs to be some planning for the few steps more. We cannot control what can happen externally, but we can control how we prepare for this. So it's summarizing key factors is critical time sensitivity, world is going faster, unique route creation, what we mentioned today, technological excellence, seamless network integration, proven vendor partnership. We had a lot of good presentation today with different partners, with the different vendors, and of course it's strategic network expansion. Yeah, I have something in pockets. It's IPv6 promo. Let's make the internet better connected together. Thank you.
Thank you, Elena. Any questions for Elena? Any questions for Elena?
I will be today at social drinks. It's maybe a little
Of course.
bit easier to ask
She's
me.
very easy to spot because she's very beautiful. So if you have any questions, you can easily find her. Shabi for details. Ask Shabi. He's Shabi.
Thank you.
Thank you. Okay, l-avem pe domnul Oacă. Mr. Oacă will present now Romanian telecommunication in this difficult years 2024. It's an election year for Romania. So we have some challenges and some proposals, interesting proposals we will hear now. de la început? Imediat. Ușor apăsați o singură dată. Mulțumesc.
Ați avut răbdare să stați cu noi până la terminarea conferinței. Nicolae Oacă e numele meu și voi prezenta o strategie de guvernare pentru telecomunicațiile românești. În contradicție cu ce a fost până acum, s-a discutat tehnic, o să discutăm mai mult strategie acum. De ce o strategie de guvernare? Pentru că în România o să avem alegeri în curând și ca de fiecare dată în preajma alegerilor propuneam câte o strategie cu speranța că cei care vor guverna se vor inspira din ea. 3 puncte pe agenda, să vedem cum stăm în anul acesta și nu suntem printre primii în Europa, când ne comparăm cu noi înșine, stăm bine, dar când ne comparăm cu alții nu stăm chiar așa de bine. Suntem chiar printre ultimii. Cauzele eșecului este lipsa de competență a celor care guvernează și punctul 3, propunerea de strategie. Ce ar trebui făcut ca să îndreptăm lucrurile? Uitându-ne la DESI, Digital Economy Society Index, iar pentru anul 2023, din punctul de vedere al acoperirii 5G, suntem penultimi în Europa. Din punctul de vedere al utilizării accesului mobil de mare viteză, stăm ceva mai bine. Locul 22, avem 5 țări în urmă. Bun, și acum vine o serie de indicatori în care avem locul ultim. Utilizatorii de e-government, suntem ultimii din Uniunea Europeană. Servicii publice digitale pentru cetățeni, de asemenea ultimii. Servicii publice digitale pentru afaceri, tot ultimii. Inteligența artificială, de asemenea ultimii. La prima sesiune am întrebat pe domnul care a prezentat despre centre de ce nu e România pe hartă, pe harta dânșilor. Și m-am gândit, poate din cauza faptului că la DESI, la digitalizare, nu stăm așa de bine. Un document mai recent, 2030 Digital Decade, arată poziția României și gradul care reușește să satisfacă parametrii Comisiei Europene. Sunt 4 mari grupe de parametri. Primul se referă la infrastructură și la infrastructura fixă stăm foarte bine. Suntem numai cu 5% sub norma europeană. La 3G stăm destul de slab, suntem cam la o treime, la 2/3 diferență. Al doilea este transformarea digitală a afacerilor și aici este prăpăd, deci tot ce înseamnă digitalizare înseamnă foarte prost. Cel mai la cloud stăm 80% aproape, inteligența artificială 98%, unicorn 100%, deci stăm foarte prost. Apoi la deprinderi digitale, cam 2/3 ne lipsește ca să fim în parametrii europeni. Ce e interesant este că pe lângă deprinderile de bază, un alt parametru, specialiștii de tehnologia informației și de comunicații. Și aici avem o problemă. 74% suntem sub parametri. În sfârșit, la ultimul, digitalizarea serviciilor publice, stăm și aici prost, cam pe medie 45% sub. Raportul dă și câteva recomandări. Sigur, să ne îmbunătățim deprinderile digitale. Interesant, la acoperirea 5G se recomandă acoperirea 5G și mai ales lucruri care sunt banale, dar cei care decid le-au uitat sau nu le știau. Sprijin pentru proiecte pilot sau cazuri de utilizare. 5G nu se dezvoltă decât dacă are aplicații. Digitalizare, unicorn, trebuie sprijinită inovarea, cercetarea, deși întâmplător sau nu avem un minister al cercetării, inovării, suntem foarte rămași în nume. La specialiști IT se recomandă măsuri pentru retenția acestora în țară. Câteva cuvinte despre tehnologia 5G în lume și la sfârșit o să vă spun de ce am ales tehnologia 5G. E o hartă a globului în care vedem cum este răspândită sau utilizată tehnologia 5G. Vedem zonele mai colorate, Europa Centrală și de Vest, America de Nord, țări din Asia, Japonia, Coreea de Sud. Dacă ne aducem către noi, observăm că utilizarea 5G-ului este preponderentă în centrul Europei, țările din vest, iar dacă mergem spre est, observăm un gradient, o scădere puternică și, în sfârșit, focalizând pe România, vedem că 5G-ul are acoperire și utilizat în marile orașe, unele zone economice și unele drumuri. Iar această utilizare slabă sau utilizare slabă este exemplificată și de statisticile ANCOM, care arată că, de exemplu, la finele anului trecut, numai 11% din utilizatori
5 minute.
foloseau tehnologia 5G, iar 1,6% din trafic era 5G. Și culmea, când 5G-ul crește, cum s-a văzut în ultimii ani, vitezele medii de descărcare scad. Viteza de descărcare crește de la 38 la 39, în schimb cea de upload, de încărcare, a scăzut puternic. De ce tehnologia 5G? Pentru că, spre deosebire de precedentele care se focalizau pe nevoile de comunicare la individul, tehnologia 5G își propune să conecteze toate obiectele realizate de om și de aici aplicații în toate industriile unei economii, în economia națională, în societate. Și de aici tehnologia 5G poate fi un factor puternic în digitalizare. Cauzele: amânarea repetată a licitației 5G din 2017 până în 2022, legea 5G care a adus 2 ani întârziere și în plus a mai adus și niște neclarități, despăgubirea echipamentului înlocuit, nu se știe cum se face, eliminarea unor furnizori, birocrația aprobării lucrărilor de infrastructură, încă, deși avem un minister al digitalizării, încă aprobările se fac ducându-te cu teancul de hârtii acolo unde ai nevoie. Tarifele mari percepute de ANCOM pentru spectrul numerotație, ANCOM a luat bani mulți pentru spectru, acum câțiva ani a avut un excedent de 100 sau 200 de milioane pe care l-a luat cu mare bucurie guvernul. Acum vrea să mărească tarifele la numerotație, astfel că ANCOM devine un colector de taxe. Concentrarea pieței: a dispărut Romtelecom, grație prestației politicienilor noștri. E posibil să dispară și Telecom Mobile, ultima rămășiță din fostul Telecom România. Un alt motiv: desconsiderarea telecomunicațiilor. Telecomunicațiile au fost considerate sursă de bani pentru guvernele falimentare, cum e cel de acum, și nu un motor de dezvoltare al economiei. Apoi de rigolanda de la Ministerul de a conducea comunicațiilor. La Minister, în ultimul mandat de 4 ani, s-au perindat mai mulți, sau niciunul, dar absolut niciunul n-a avut tangență cu telecomunicație, decât poate că știa să folosească telefonul mobil sau internetul. Dacă ne uităm și la secretarii de stat, poate 1-2 au tangență cu IT-ul. La ANCOM, ce să spun, situația este dramatică. ANCOM este autoritatea care monitorizează o industrie tehnologic de vârf și a fost pus la conducerea ei. Da, mulțumesc, 3 minute. A fost pus la conducerea ei o echipă care total nepregătită. Președintele executiv este absolvent de drumuri și poduri, ce-o fi având drumurile și podurile cu tehnologia informației, greu de înțeles. Vicepreședinții, unul este specialist în pază și protocol, celălalt nu știu ce facultate particulară a făcut. E bine, aceștia 3 trebuie să conducă telecomunicațiile noastre. Închei cu ultima: lipsa specialiștilor, numirea unor, să zicem, pafariști în conducere a dus la situația care este de acum. Acum, scuze, nu știu cum să mai pornesc. Mai îmi dați ceva de timp?
Sigur, cum să nu s-a întâmplat ceva cu proiectorul? Ne ajutați? Că de aici pe ecran se... proiectorul
a murit?
De la aici n-are decât înainte înapoi și... Gata.
Gata? Dați și...
Nu mai apăsați pe ăsta, de jos decât la mare.
Ăsta.
Mai sus un pic.
Da. Deci ce ar trebui făcut? Ținând seama că, de faptul că cel puțin în ultimii 4 ani, dacă și nu mai mult, la conducere s-au perindat persoane care n-au tangență cu telecomunicațiilor, câteva recomandări, un prim capitol, guvernanță, depolitizarea, deparazitarea instituțiilor statului care nu numai că nu și-au făcut datoria, au frânat dezvoltării telecomunicațiilor și numirea de profesioniști în funcții de conducere scurte la Ministerul, autorități, companii de stat, comunicații, Consiliul de Administrație. Reînființarea Ministerului Telecomunicațiilor, era băgată și cercetarea aici, cercetarea și are rolul la educație, nu aici. Ministrul Telecomunicațiilor ar trebui să aibă rang de prim viceministru ca semn de recunoaștere a importanței telecomunicațiilor. Apoi, legislație predictibilă și favorabilă competiție, păstrând un număr adecvat de concurenți. Acum pe piață sunt 4 concurenți. Dacă dispare Telecom Mobile, vor fi 3. Și ce se întâmplă dacă rămân 3? Vedem exemplu din Statele Unite, unde fuziunea dintre T-Mobile și Sprint a dus la scăderea operatorilor la 3, iar aceasta s-a văzut pe piață un plan tarifar care cu 50 de gigabiți i-a crescut prețul de 3 ori. La noi, probabil că nu va crește de 3 ori, dar sigur va crește dacă va dispărea Telecom Mobile. Accesul de mare viteză în sfera serviciului universal sau în Constituție. Sunt țări care au pus accesul de mare viteză în Constituție. Poate că ar fi cazul și la noi să o punem, nu de alta, dar aceasta ar însemna conectarea tuturor localităților de la sate la internet și conectarea acestora la PIB-ul țării. Posibilitatea de a-și face cunoscute produsele lor. Deci economia locală ar crește și PIB-ul. India discută posibilitatea de a oferi internet gratuit. La noi cred că n-ar avea rost să discutăm, de vreme ce avem un guvern care este flămând după bani. Administrarea profesionistă a activelor de stat de telecomunicații deținute și am pus aici 3 telecomunicații CFR, Teletrans, Radiocom, care sunt companii de stat, brațul de telecomunicații al unor mari operatori. Radiocom, dacă va dispărea Telecom Mobile, Radiocom ar trebui să intre ca al 4-lea jucător. E companie de stat, dacă am păstrat 4 operatori, ar fi foarte bine. Denominarea în lei a tarifelor serviciilor de comunicații, mobile și fixe. Românul este plătit în lei. Dacă te duci în obor și cumperi un kil de ceapă, îl plătești în lei, nu în euro. Deși tarifele din telecomunicații ar trebui denominate în lei. Ultimul punct de la acest punct 1, răspundere pentru actul de guvernare. Cei care vin la guvernare ar trebui să răspundă, așa cum un director executiv de la o entitate lucrativă este angajat cu un anumit obiectiv și suferă consecințe dacă nu le realizează, așa ar trebui să se întâmple și cu cei care sunt numiți miniștri sau în alte funcții. Tehnologia 5G, 2 puncte aș vrea să spun de aici. Un lucru important, extrem de important, dat fiind faptul de numărului mare de piloni care sunt și aprobarea dificilă a lucrărilor de construcție, ghișeul unic online ar trebui să fie o prioritate a noilor guvernanți. Până acum, dacă vrei să pui un stâlp, te duci cu un tank de hârtie undeva în comună și aștepți câteva luni să-ți dea aprobarea. Ei bine, ar trebui un ghișeu online, undeva știu eu la Ancom, sau nu știu unde să depui un fișier format digital, bineînțeles, și să obții aprobarea după câteva săptămâni, după câteva zile, scuze. Se poate asta pentru că Ministerul Digitalizării ar trebui să digitalizeze și telecomunicațiile. Se putea asta pentru că coaliția de guvernare putea să o facă dacă voia. Ei n-au vrut să taie pensiile speciale, deci arată că pot, deși mulți s-au ridicat împotriva acesteia, deci puteau să facă și acest lucru. Și apoi, proiecte pilot, extrem de important pentru abordarea 5G-ului. Proiecte pilot în diverse industrii, de exemplu, orașe inteligente, agricultură și așa mai departe, ar da un impuls tehnologiei 5G și digitalizării. Ce ar trebui făcut pentru tehnologia 5G? În primul rând, ghișeul digital unic online, reducerea cheltuielilor operatorilor. Extrem de important. Ancom s-a transformat în colector de taxe pentru guvern. Nu știe ce taxe să bage ca să ia din buzunarul cetățenilor prin intermediul Ancom. Una din acestea sunt tarifele pe care le percepe pentru spectru, și recent vrea și la numerotație. Apoi, despăgubirea pentru echipamentul care se cere a fi înlocuit după legea 5G. Pe toate țările care au cerut operatorul să scoată echipamentul au făcut acest lucru. Proiecte pilot 5G finanțate de guvern. Și ultimul slide. Deci, cum am spus, ar trebui creat Ministerul Comunicației, Digitalizării și am adăugat și inteligenței artificiale. Am citit recent că Franța a numit în nou guvern pe care îl face acum un minister pentru inteligență artificială. Inteligența artificială este un boom. Se investesc miliarde de dolari în ultimul an, de companii private sau chiar de state. Franța și-a propus să devină să are veleități în acest domeniu și din cauza asta a numit un ministru pentru inteligență artificială. La noi, măcar dacă ar fi o preocupare a Ministerului Comunicației și Digitalizării, ar fi foarte bine. Apoi, oameni potriviți la locuri potriviți. Am văzut că suntem conduși de nepricepuți. După modelul italian, guvernul Draghi, dacă vă mai aduceți aminte, acum câțiva ani, avea la Ministerul Cercetării, Ministerul Digitalizării și Comunicațiilor, o personalitate a telecomunicațiilor, Vittorio Colao, care mulți ani a fost director executiv la Vodafone. După modelul italian, am putea și noi pune un profesionist. Și am pus aici câteva nume. Vă mulțumesc pentru atenție.
Mulțumim, domnul Oacă. Întrebări pentru domnul Oacă? Da, imediat. Țineți microfonul că aveți de răspuns.
Mulțumesc frumos. Mihai Stan, la buticul SRL. Ce vreau să vă spun, domnul Oacă, lăsând la o parte politizarea, n-am auzit nimic despre creșterea tinerilor, despre nivelul de securitate în instituțiile de stat. Veniți să ne spuneți că ia în comul bani. Probabil că aveți o funcție politică undeva. Ce face ministerul în afară de faptul că ia bani? Aici sunt reprezentanții unor firme private care muncesc pentru bani. Știți de ce s-a dezvoltat România? Pentru că a avut parte de acele firme micuțe care au dezvoltat rețele de cartier cu firele alea trase acum 20 de ani, acum 25 de ani. Așa, ce ați făcut dumneavoastră ca să creșteți tineri, să-i ajutați să devină mai buni? V-ați întrebat vreodată ce ați făcut? A fost acum cineva cu un copil sponsorizat de chinezi la un concurs de fibră optică în China. Știați treaba asta? O firmă românească nu-și permite să dea bani să trimită un copil acolo. Da? Deci, mă scuzi? Te rog. Da, mulțumesc frumos. Deci faceți ceva pentru tinera generație și pentru administratorii de rețea care lucrează și nu o să mai avem probleme de securitate. Asta faceți. Și o să vină și vremea când o să puteți să puneți echipamente 5G de orice tip pe toți stâlpii din București. Franța a început acum 20 și ceva de ani cu Minitel și a pus echipamente GSM pe fiecare stâlp. Care-i problema? Mulțumesc.
Da, pot să
mulțumim.
răspund?
Sigur, vă rugăm chiar.
Da. În primul rând, n-am nicio funcție politică, n-am de a face cu niciun partid. Toate sunt echidistante, unele chiar mai distante prin prestația care o au. Am ieșit la pensie de la Ancom acum vreo 10 ani, circa, sau 11 ani. Și de atunci, dacă... V-am lăsat să vorbiți, lăsați-mă pe mine. Și de atunci, dacă ați fi urmărit evenimentul, de exemplu pe internet, ați fi văzut că am luat poziție totdeauna contra incompetenței și contra nedreptăților care s-au făcut în industrie.
Mulțumim mult, domnul Oacă. trebuie să recunoaștem că este o prezentare foarte transparentă, să zicem așa, fără perdea. Mulțumim mult! Mai avem o scurtă prezentare din partea celor două Internet Exchange. Avem de la Internet Exchange pe Eric Băleanu și urmează și de la Ronix Radu Ghidicianu.
So I think we have a few minutes each. So I will try not to be long. A short update from Internet Exchange for Ronog 9. Internet Exchange is a distributed exchange platform in Romania, which is available across 16 strategic locations, enhancing connectivity and network resilience. Bucharest is the home to 7 key facilities, which is serving and is serving for as the central hub for Romania's traffic. We also have 7 additional facilities in the major cities: Arad, Cluj-Napoca, Constanța, Craiova, Iași, Suceava, and Timișoara. These sites extend the reach and improve service quality across the country. We also have 2 facilities in Europe, in Frankfurt and Sofia, for international connectivity and traffic exchange with major global networks. This is our map of the network of Internet Exchange. It's Bucharest linking the main cities in Romania, and we have a ring between Frankfurt, Bucharest, Frankfurt, and Sofia. So, why distributed? I will tell you now a few words about our distributed model. As I told you before, the central hub is in Bucharest, where the main present points are located. Smaller distribution points throughout Romania are primarily aimed at assisting local operators to connect to the IX. And of course, these are crucial for reducing latency for local traffic. They are keeping local traffic local in those cities, but also help local operators to reach Bucharest, where the main hub is. The distribution points in Frankfurt and Sofia are tailored for the major international operators and content providers. These are not local exchange points, so these are only gateways to Interline X platform. So this configuration allows Interline X to support both local and international connectivity, and it makes a truly distributed exchange. They make it a truly distributed exchange, and it helps local operators to improve performance while enabling global reach for larger entities. Our daily peak traffic is almost 600 gigabits. This is not so updated graphic, but now we have our daily peak traffic is 600 gigabits. We have 400 G ports available, but no one is connected yet. We have 22 ports of 100G connected, 3 ports of 40G connected, and 129 ports, 10G ports. We still have 1G ports, but we are not offering them anymore because we are trying to reduce them. As I said, available ports 40G are available. The 40G ports are available in NX Data 1 and NX Data 2. Also in Equinix FR5 Frankfurt and Telepoint Sofia. 100G and 40G ports are available in Bucharest, Frankfurt, and Sofia. In Bucharest, in all the facilities, and also 10G ports are available everywhere. We have a TV exchange media platform. This platform is used to broadcast and receive audio and video streams via multicast technology. It is operated on a dedicated VLAN usually. Supports multicast, SPTS, and MPTS. And we have dedicated servers and Arista switches in NX Data 1 and 2 that are managing the TV streams and doing all the job. So we have in this platform now over 200 TV channels available, and the number is increasing. This is a diagram showing how it works. So the TV channel are sending the stream to the cloud is Interlan. So the TV channels are sending the stream to Interlan, and Interlan is delivering via multicast to this signal to the stream to the broadcasting station, which are the ISPs connected to Interlan Internet Exchange, and then they are delivering the TV channels to the final client. Our services, broadband connectivity. So we are connecting 135 ASNs for now from Romania, but as well as from the region and worldwide. We provide multicast streams, as I said before, via the TV Exchange platform. We host 5 DNS instances, D, E, F, K, and L, and we offer AS112 service. We have 2 route collectors. One is from RIS, from RIPE-NCC. RIPE-NCC doesn't receive, for now, new BGP sessions, but I think this will be corrected in the near future. And we also have the BGP tools. You had the presentation earlier for Ben Cartwright-Cox here. So it's a new collector installed at Interlan recently. We also host an NTP time server, and this server is member of the row.pool.ntp.org zone. And we also have 2 speed test servers. One is from UCLA, and the other one is from NPerf. I saw some NPerf data in Mr. Walker's presentations earlier. We also use ISP Manager for peering management, and we are fully MANAS compliant. About now a little bit of enhancements in the future. We are planning to upgrade our ring in Bucharest. Our ring is now on 40G capacity, but we have plans to improve it to upgrade to 100G. We have 7 POPs on this metropolitan ring in Bucharest. Of course, we will use new NOKIA switches, and NOKIA switches which we are already using in the new POPs we implemented in Târgu Secuiesc and Gheorghieni. These are new POPs which will be available soon. And now we are operational. Sorry, we are trying to put in place the new POP in Sofia. About the capacity, we have the new 40G ports, and we have specific plans to introduce new 800G ports in the near future. And all of this with, of course, our new NOKIA switches. The implementation of NOKIA switches has improved the traffic management using the new technology CVPN and MPLS. The core switches, the core NOKIA switches are at NX Data 1, NX Data 2, Equinix FR5, and Telepoint Sofia. And we also are, we have plans to develop a new web application for infrastructure management, which will be available, I hope, until the end of last year. This application will enable the visualization, the control and management of service infrastructure and equipment for interline internet exchange. We like to host events. So we are hosting the Ronog meetings in 2014.
You like to host events.
We like to host. Besides Ronog meetings, we hosted 2 URX forums, one in 2014 and the other last year in Cluj-Napoca. RIPE meetings, a lot of RIPE meetings. We had the RIPE 71 in 2015, RIPE SE meeting in Timișoara in 2018. We had the Internet Measurement Day yesterday before Ronog. And of course, the IRON meeting from Internet Society, which was hosted with Ronog in 2016. Our future plans to host events are the Bucharest, the European Peering Forum in Bucharest, which will be, we will not be a host, but we will be the guest IXP for this event. Ronog will be right after this European Peering Forum in Bucharest. And also RIPE 91, 1 month later, at the end of October, it will be here at Marriott Hotel in Bucharest. So be prepared for a lot of interesting events next year. Besides the events, we have a lot of contributions to the community. We are sponsoring the IXP Manager project. We are sponsoring also the PeeringDB project, and we translated the Romanian interface of PeeringDB. So this is, as I said before, during Livio's presentation, I said that Romania is the only language which is 100% translated. So it's fully translated. So if you have any complaints, you should tell us about the interface in Romanian, the PeeringDB interface in Romanian. We also are a sponsor of IXPDB project, and we realized the Romanian version of the first URX film, Internet Revealed. You can find it on YouTube. Resources about us, you can find us on our official website, on social media platforms, on PeeringDB, of course, and other databases. You will have the presentation later on the website, and you can see, you can have all the links if you want. Okay, stop. Questions, if you have, if not.
Mulțumim frumos, Eric Băleanu.
I will be at the party tonight, so can you ask me a question? You can ask me a question there. Radu, please.
Okay, so we have the last speaker of the day, Radu Ghidicianu. Radu Ghidicianu from Ronix.
Pot să fiu și eu primul în felul meu?
Primul întotdeauna de la sfârșit spre... Da, corect.
Am pus un slide aici ca să știți unde mă găsiți. O să încerc să fiu scurt, așa cum știu, trebuie să mergem la acel party care a fost anunțat, dar o să mă găsiți acolo și mă mai găsiți și la aceste coordonate. O să vă spun câteva vorbe despre Ronix, internetul exchange pornit de noi în 2001, deja avem 23 de ani, aproape 24. A fost constituit de cei mai mari operatori la momentul respectiv care erau pe piață în 2001. Ce înseamnă operatori mari la momentul respectiv? Cei care puteau să aducă capacitate să cumpere capacitate din internațional și să o vândă pe piața locală. Am pornit cu acest aspect cu operatorii mari, fiindcă, deși asociația noastră s-a modificat, au intrat operatori mai mici și acum asociația este o asociație destul de eterogenă, totuși modul în care am pornit a determinat locul în care am ajuns astăzi. În ANISP, toți operatorii, fiindcă ANISP-ul este asociația, iar Ronix nu este decât un proiect, Exchange-ul este un proiect și este manageruit de Asociația Furnizorilor de Internet, unde toți membrii sunt egali. Nu există la noi prea mare sau prea mic, toți pot fi aleși, participă la alegeri, pot fi aleși în Consiliul Director și decide. Taxele de interconectare sunt decise de membri, pentru ei nu este o societate la care să plătește, deci avem în vedere acoperirea costurilor doar. Acum, ce aspecte se discută la Internet Exchange-uri? De exemplu, unul ar fi acoperire. Când membrii sunt internaționali, cel puțin jumătate, ei sunt deja prezenți în diferite țări din Europa și din afară. Motiv pentru care politica noastră a fost să rămână exchange-ul național. Nu am avut tendințe de expansiune, să mergem pe alte piețe, să aducem traficul de acolo. Se presupune că operatorii străini care au interes de interconectare pe piața românească vor veni ei aici la noi. Până la urmă, ce mai costă astăzi o conexiune internațională de transport? Deci nu ne-am dus noi după ei, ne așteptăm că ei sunt deja foarte mulți în România. Alte aspecte ar fi tipurile de echipamente. Echipamentele, noi am mers de la început pe Cisco. Cisco a fost destul de tradițional, așa, destul de conservator. Nu mai avea cota de piață pe care a avut-o în 2001 când am pornit, dar până la urmă noi ne-am decis că un factor important este stabilitatea rețelei. Membrilor Ronix nu prea le place să fie tulburați, să schimbăm, să cadă, să se reruteze traficul, vor să fie stabili. Și atunci stabilitatea rețelei a fost un aspect important și când ai un switch cu un uptime de 10 ani, deja aș zice că este de încredere. Am avut în vedere și reziliența, popurile principale să mai aibă un nivel de redundanță. Ei bine, și nivelul 2, în caz că cade vreun switch de la primul nivel, tot Cisco sunt. Și lucrurile au mers bine. În privința capacităților, vitezele de interconectare la 100 de G deja nu mai sunt ceva deosebit, prețurile la optice au mai scăzut și atunci am observat o tendință a membrilor care, dacă chiar n-au ajuns la 10 giga trafic, cer port de 100 pentru un timp de răspuns mai bun. Nu știu ce aș mai putea să vă spun. Despre acoperire v-am spus, despre echipamente redundanță. Un aspect interesant este operatorii internaționali sau români care sunt deja internaționali, în momentul în care primesc trafic neașteptat, să zicem, dacă vreau să aduc niște AS-uri care nu prea sunt din România, sunt destul de reticenți, în sensul că ei preferă să-l preia în alte puncte de interconectare din rețelele lor internaționale și să nu îl aduc aici și să-l anunț neașteptat la toți, fiindcă nu îl vor aici. Ăsta a fost un motiv pentru care s-a decis ca Ronix-ul să rămână un exchange național. Sigur, avem conexiune și în Frankfurt, dar așa cum probabil ați văzut, nu prea strigăm acest lucru, fiindcă este pentru alte necesități și așteptăm operatori mari care sunt interesați și văd din ce în ce mai mulți străini la această conferință, probabil că interesul pentru piața noastră locală crește. Mulțumesc!
Mulțumim frumos, Radu! cum zice românul, that's all folks. Întrebări pentru cei doi reprezentanți de la cele două internet exchange-uri, Interland și Ronix? Dacă aveți ceva întrebări, curiozități, ne vedem la petrecere și puteți să-i asaltați acolo, da?
Foarte bine.
Perfect.
Vom
Mai
fi
ales
acolo.
domnișoarele cele mai drăguțe să asalteze băieții cu întrebări. Avem un concurs pentru voi de final. Mulțumim în primul rând. Scuză-mă, Radu. Mulțumim tuturor pentru că ați venit în număr atât de mare. Vom avea ca de fiecare dată tradiționalul concurs Kahoot. So as usual, at the end of the conference we have Kahoot contest. So everybody should install the app on the mobiles. Of course, if you want to be the lucky winner. So today we have from EXA Infra. So Isabella is here. So Isabella, our friend, she will be okay. She will hand over the prize, the first prize. It's an electric scooter. Okay. Also, we have some other prizes for the second and third place. Jackets, small things, but I think everybody will aim for the first prize. So if you paid attention during the event at the presentations, you get the chance to get a scooter. So only 10 questions. Only 10. 10 questions. Okay, so we are coming. Instalați pe telefonul mobil aplicația Kahoot. Nu știu, nu am pregătit eu întrebările, o altă colegă de-a noastră s-a ocupat. Stinge lumina. Bun.
Lasă-l sau îl scot. Îl scot? Păi...
Nu o să-l pornesc. Okay. So everyone Everyone who wants to join the game, you have a PIN code. You just enter the PIN code. Sabotaj. Eric, nu mai atinge ăsta că este conexiunea de la No Signal. Eric a reușit să rezolve. Să o rezolve. Ne ajuți? Încercăm. S-a oprit, nu.
Ok.
Avem pe monitorul de aici, dar it's okay now.
E bine.
Ok, so toți cei care doriți să intrați în joc, aveți un cod PIN pe care trebuie să-l introduceți în aplicație ca să vă logați la acest concurs. În sauna? Nu e sauna? Nu avem saună, bine.
Mai avem încă 7 locuri.
De ce că
6.
Mai avem până la peste 50. Avem de la mare, nelimitat 200. Cred că 50? 5 more. Încă 5 persoane se mai pot... De pe mai multe device-uri, nu știu dacă reușești pe același cont.
Mai avem 4 locuri. Mai avem încă 4 locuri. S-a eliberat unul, mai avem 5. Bun, o să începem în curând, nu mai așteptăm după cei 5, să vedem dacă ajung sau nu. Oricum, puteți intra și în timpul jocului, doar că o să plecați de pe o poziție mai slabă. Deci, mai avem acum încă 4 locuri.
Dacă cineva e în curs de instalare, ca să nu-l pornim, ridicați mâna să mai așteptăm câteva secunde. Dacă nu, putem să-l pornim. Ok, if anyone is already downloading or installing the app, just let us know so we can wait few seconds more. Oh.
So if you pay attention to the presentation, so you know the answers. If not...
Okay, yes. Part of the questions are from all the presentations from today.
I will push the button.
Are you sure? Okay, everybody ready?
So
steady.
We have the pin. Okay, start.
Start. Așadar, what is one of the general requirements for a typical data center interconnect, DCI scenario?
Low bandwidth and high latency, complex setup with many DWDM experts, high bandwidth and low latency, or no need for space for power savings.
Oh.
Okay.
Well done. Well done. Merge singur. Lasă-l, lasă-l. Nu cred că trebuie să faci nimic. Da? Next? Oh.
So,
Okay.
this is the first top after the first question. the second question. If NetFlow were the detective, what mystery would it solve?
Who stole the router? Who's downloading CA? Where the encrypted traffic is coming from? Romanian Neutral Operators Group.
Well, we have the right answer, and the majority was right. Let's see how the top looks. Okay. So we have AS 39531 in top, Alex and Răzvan.
Okay, so the next one. Okay, guys, so the faster also is very important. What is the distance supported by QSFP28LR for transceiver in a PAM2 modulation SCH?
40, 80, 10, or 2 kilometers. So the answer should be easy.
Module QSFP 28 LR4, long range 4. Hai să vedem. Ok, nu ați fost atenți. Penalizare.
Okay.
Ia să vedem.
Let's see now how the top looks. Oops, there are some
Răzvan,
changes.
Luci Connectix.
And Victor T is the
Victor
highest climber.
T. Victor T.
Okay, let's go next.
Let's see the next one.
What kind of data does BGP tools frequently update?
OSPF routing tables, MPLS forwarding tables, ICMP ping data, reverse DNS data, and forward DNS data. SNMP monitoring data.
2, 1. Well,
okay.
They paid attention, so
yeah.
they know. Okay.
Well done, let's see. Răzvan Luci Connectix. Butterboard. BGP tools.
BGP tools
Come on,
is the
Ben.
highest climber.
Come on, Ben.
He was, I think, the fastest. Okay, next. ServiceFabric sounds like a new fabric for clothing. What does it actually do?
Makes you a tech-savvy fashionista. It's used to gather servers racks, helps connect clouds, data centers, and people, creates digital kills for the internet. Pam pam.
And it helps connect clouds, data centers, and people sit. Okay, let's see how the top looks now. The scoreboard. We have Răzvan in the first place, Connectix on the second, and I win on the third place. Let's see the next question. It's the 6th out of 10 questions.
Which security feature is supported by Nokia's network processors?
IPsec TLS encryption, AnySec and MACsec, WPA2 encryption, radius-based authentication. You have 8 seconds more.
And 3, 2, 1.
AnySec and MACsec. Okay. Oh, they paid attention. The scoreboard looks like Răzvan is the first place. On the first place, Connectix, so nothing's changed. We have the first 3.
Okay, we can
same.
go to the next one.
Okay.
If RPKI were a chief, what would it be best at cooking?
Delicious encryptic soufflés, perfectly signed certificates, spicy packet validation tacos, gourmet raw pizzas.
So RPKI. Let's see.
And the answer is perfectly signed certificates.
ROA. Perfect. Let's see who knows about ROA.
So the scoreboard changed. Răzvan is on the first place, I win on the second, and Alex on the third. The eighth question, what is one of the key advantages of multi-fiber connectors over simplex connectors?
They have lower bandwidth, they are easier to clean, they allow up to 72 fibers to be connected, they use fewer alignment pins.
And they allow up to 72 fibers to be connected, of course.
And
let's go to the scoreboard now.
No surprise, Răzvan is on top. Okay, maybe the next one, you are maybe faster.
If TP-Link's Omada cloud
Solution.
were a party, what kind of party would it be?
A wild pool party, a perfectly managed high-tech networking event, a rooftop Wi-Fi bash, a gaming marathon with no lag.
And the correct answer is a perfectly managed high-tech networking event.
Right.
Okay. And next, the scoreboard. So we have some changes on the scoreboard. Răzvan is on the first place, I win on the second, and Vân Golf 4 is I sell Golf 4 is for non-Romanian speaking. We have one more question. Is the last question. If the internet were measured in horsepower, it takes how many horsepower to run the internet today?
5 million, 500 million, 50 million, 5 billions.
Three, two, one.
And bam bam.
50 million. Okay. We should see the scoreboard now?
I think so.
Now?
Now? Let's do it now.
Or we can wait a little bit more?
Maybe. How's the weather today, Eric? How's the weather? There is any sun outside?
It's sunny outside.
It's sunny. Great.
Let's see the scoreboard.
Let's see the scoreboard. And
So, on the third place, Sorin
BMW. Welcome. Come.
I win, and on the second, and on the first place, Răzvan. So, congratulations, Răzvan. You are the happy winner.
All the winners. Câștigătorii să vină în față. Premiul 3, pentru premiul 3. Hai jos.
Ok. I win și Sorin Sorin, da, sunt invitați să-și ridice și ei.
Who's the second one? You win. I win. Okay. So, okay. Second. Only because it's volumare, dar... La sfârșit. Mulțumim, mai win și l-avem și pe Răzvan. O rugăm pe Izabela să înmâneze premiu. Mulțumim frumos de la Exa Infra. Mulțumim frumos tuturor. Câteva cuvinte de final din partea lui Eric.
Ok. Nu părăsiți sala, că mai avem câteva momente de final. Bun. Și acum, la final, aș dori să invit membrii Comitetului de Program care sunt în sală să vină aici, să le dăm un mic premiu pentru contribuția lor la conținutul acestui program. Sus aici pe podium, vă rog frumos, ca să facem și o poză de grup. Membrii Comitetului de Program care sunt în sală, care sunt bine, care nu sunt, nu sunt. Ok. Să fac eu oficiu de... Trebuia să vină, dar lasă că ne descurcăm. Ok. Dacă le-am încurcat...
Și ție cine îți dă?
Mie îmi dau singur. Vai, mulțumesc.
Le invităm și pe Eric aici. Le mulțumim tuturor pentru implicare și pentru voluntariat, pentru programul de astăzi. Fără munca acestor oameni nu ar fi fost posibil să aducem atâtea prezentări și conținut de valoare. Sperăm că ați învățat lucruri interesante, ați văzut tehnologii noi. Sperăm să ne vedem și anul viitor. Mulțumim Comitetului de Program, mulțumim vouă pentru participare și de asemenea sponsorilor. Hai.
Mulțumim încă o dată sponsorilor: Digital Realty, IPXO, Internet Society Foundation, TP-Link, EXA, Telegroup, Salumanus, Smart Optics, Nokia, Flex Optics, EncryptNet, NX Data, Noxion, IP Host, CA Jute, Genie Networks, RIPE-NCC, Netera, RETN, Sphere, Eco, Infinity Telecom, Viva Telecom și gazdei Interland Internet Exchange. Și ultima întrebare din această seară: sunteți gata să aniversăm cei 19 ani? Dacă da, vă așteptăm la Naiv. We are waiting for you from 7 o'clock tonight, this evening at Naiv for our anniversary party of Asociația Interland. It's our 19th anniversary. And now, please, let's take a group photo. So everybody should come here on the stage and we'll make a big group photo with everybody.